I knew. So, all right. My apologies on that, folks. But again, it wasn't like we revealed secrets of the universe. So pardon the 1 hour gap, the hour and a half gap in the video. So now, a couple of other things, so sort of nuanced uh, pieces um, to our modeling. Let's take a look at using two different sources of information here. If I look at this data, and I'm not going to load it up in the viewer. I'm just going to spin it up here and I'm going to show you something. When I look at this data set, I see I've got some spot elevations, some contour lines, and all of those break lines that are elevated, whereas everything else is down here just planimetrics. Just, you see, there's that curved line, for instance, that's down at zero elevation. And in plan view, it's directly underneath the 3D lines that have elevation. Okay, so this is just stuff that helps the drawing. And one of the reasons you might want to have those as separate things, now these are not done that way, but if they were, sometimes these are drawn as true circular arcs, and then you could label them with the radius of that arc segment, whereas the equivalent structure up here is not an arc, it's those little individual chorded segments where, that's the only way it can represent that. So there is no radius here. They're just chorded segments. Now it happens because this is compiled photogrammetrically that this is also just drawn segment, segment, segment. It's not drawn as an arc. But if I were actually compiling this to be and particularly if this was if this were a design, I'm going to have a design. I have a certain length of my parking bay. I have an island here, and I've got a radius on the nose going around the island, and all that stuff gets labeled on my drawing. So that's why you would sometimes have these as two different lines, one right on top of the other when you're looking down on it straight down from plan view. So, but now, so the only things that are going to be considered for my terrain modeling are the things with elevation. Now, we've already seen where if we're trying to use both contours and break lines, that we're going to have problems with all those crossings. So let's take a look at this in two different aspects. I'm going to go back, hit my top view of my cube and go back to my plan view. So what I want to do is I'm going to look at, and again, we have this as part of our sometimes have to do workflow, if you put quotes around all of that, because that's all we have are contour lines. And I know you guys get that concept, but here's what I also want to illustrate that a lot of people, uh, they'll make this trade-off and without getting the precision that they can get out of this if they do things correctly. So what I want to do first is to look at contours only, as if we're going to make our surface from the contours. So a nice way of doing that to keep from having to keep stumbling around everything is that we know the only thing that's elevated are those contour lines and the break lines. So let's isolate the layer. So we're going to go to the view menu and we're going to isolate layers. And we're going to just zoom in here. I'm going to pick one of those index contours, one of the intermediates, and then also go off to the either side here where those dash contours are and get one of each of them. So we've now identified the 4 layers. We hit enter to finish. And now the only thing that you see here are the contours. Okay. Now we look at that in our 3D viewer. And you can sorry, you can see that, well, indeed, that, gives me a sense of what that ground looks like. It's a good representation of the surface. However, remember, it's the output. It's not the input. It's not what defines the surface. The surface has defined these, okay? But still, it's there. It's recognizable. It's a way we're familiar with it. We can see all that, all right? So let's build us a surface. So let's go to the profile. Go to the surface menu and choose triangulate and contour. Now, we're going to play around with a couple of these switches to see what they do for us. If we look at our selection tab in the far right, we'll make sure nothing's checked there, so no filtering is going on. We look at our contour tab and make sure, let's not draw the contours. We've seen that, we beat that horse till it's dead and then some, where the contours will come up and they'll square off and have those flat areas in there on those flat contours, okay? So make sure that's not drawing. We've already got drawn contours. We can always use them for the picture. Then on the triangulate tab, let's write the triangulation file and choose select. Making sure you're in your folder, and I'm going to call this one EG-CTRS only. So existing ground contours only. I'll hit save. And the only thing I want to see here is inclusion exclusion is unchecked. Shrink wrap perimeter reduction is set to none. Erase previous contour entities. It doesn't matter for right now. We'll just leave it off because we're not going to draw them. And we'll ignore zero elevations. Everything else we leave unchecked. Okay. Go ahead and choose OK. And read the prompt. Select the entities. The line above it says select the points and break lines to triangulate. Well, that's all we got. The contours. Those are our break lines. We hit enter. Off it goes. Now here's where the problem comes in. Because look, this thing ran, it came back and it said writing triangulation file, EG contours only .10, bada bing, bada boom. It did not kick up the error messages. So yay me, I've built a surface, right? And that's where I've seen so many trainers do this where they'll have people do it this way. And they'll step them through the process of selecting the contours, and the surface gets built and there's no errors reported, and they go, congratulations, you now know how to model your surface. Yeah, take a look at this surface. That's the difference. So I'm going to go, now notice I'm going to pull this from these icons up here a minute. I'm on this, I've got my surface toolbar out, and there's one that looks like a cube. That's my viewer 3D viewer, my drawing 3D viewer. And two away, skipping over the airplane, I've got the surface file viewer. So that's the same as pulling down view, 3D view, drawing viewer, and surface file viewer. Notice those two little icons in the menu.
Yeah, I don't have the surface toolbar.
You don't have it showing. Okay.
Yeah, it's not I guess docked, I guess.
Right. So here's how to turn those on. That's really the reason I wanted to point this out. Is go over to some of the gray spot and right click the mouse, and then you should see show toolbar.
Yeah.
All right, and you've got Carlson toolbars, you've got CG Survey, you've got iCAD. So these are all different ones and different ones you can have on. And now you see the ones that I've got on and they're arranged here, but I'm going to show you another way of doing that instead of necessarily right clicking that is go to your settings menu and choose your toolbar setup, which is like right smack in the middle.
Yeah.
And that's going to give you this list that you can scroll and turn these on and off. And you can choose Carlson versus iCAD versus DGN mode, various ways. So the one that I'm using these viewers from, and really I use three icons on that toolbar a lot. There's two 3D viewers and the far left one that says triangulate and contour. But for that, I've got the whole darn toolbar sitting up there, and I use, most of those other things I don't use. Well, it's just what I gotten used to. Now, so that one is, scroll down here and I see surface. So that one is checked on. That's the one I got up there. Another one I use quite a lot is this properties. It's what they call entity properties. And you'll see it right here checked on. And that's the one that, and I don't ever use any of these pull downs where you can change the layer and the color and line type and all of that. I use it almost exclusively just to get that one little button right there to the left of it. And that is the same as my, on the view menu, choosing layer control. Okay. And that pops up that place where I can change the layers and the text styles and the XREFs and drag and drop between drawings and all that kind of stuff. The other one I find quite useful is this one up here, which is Carlson's layers toolbar. Okay, and so you'll see down here, it will say layers, and that's from the Carlson. Now notice if I pull this category down and choose the iCAD, there's also a layers here that I don't have showing, but it has some similar functionality, but not the ones I'm after. So the ones I want with this layer toolbar is all of these view controls that I've been telling you. Go to the view menu and choose isolate layers. Go to the view menu and choose layer control. Go to the view menu and choose freeze layer by pick. Or go to the edit menu and choose erase and erase by layer. So those are things I use all the time, and they're all contained on the layers toolbar. Okay, so I'm going to cancel that just to show you here, and I'm hovering over those particular little vertical line of dots. That's the handle of the toolbar. And if you hover over it, that'll tell you what toolbar is up there. And for instance, this top one here is my inquiry. So I can, you can pull that down, you can dock them vertically, put them on the top, the bottom, wherever they want to go. Now, for instance, the inquiry, I use that for this standard distance, the drawing inspector, and again, I usually teach from the menus, but that's where they are. The other really uh, important and helpful one is this polylines toolbar, because I use this remove polyline vertex and remove polyline segment. I do that all the time, and join nearest and change direction and 3D offset. So those are all things I use quite a lot of, and yet they're buried. They're in a place like edit, polyline utilities, remove polyline segment. So instead of going click, 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 click to get my command, I can just pick it once off the toolbar. Okay. Now here is a little tool that somebody showed me in a class that I was teaching. I think it wasn't the Mississippi trip. It was a construction company, and they had people but it was exclusively for their company. But they had people in various offices all over the country. Anyway, um, they told me about this command that I had no idea. I'd never run it before. I didn't know it was there, but it's so useful. I want to make sure everybody hears about it from now on. But I used to tell people that as you're getting to know the software, look at these menus, and when you see a command that has an icon to the next of it in the menu, then that tells you that that command exists on a toolbar somewhere. It doesn't tell you which toolbar, and you have to sort of logically think your way around. Like the edit erase by layer tool is on the layers toolbar. It's not on the modify toolbar. There is a modify toolbar, but it's not where that command is. It's made more sense to put it in the layers toolbar. So you were sort of left on your own to figure that out. However, somebody says, "Oh, I like this command called." There's a command called command help or something. I forget what it's called, but I'll show it to you. And it's been here all along. It's on the help menu, and it's right here called command search. Okay. It's also available on here's my help toolbar, which I don't generally use a lot, but it's here as Carlson help, IntelliCAD help, Carlson Academy. There's the command search. And so these are all different things. There's some online movies and different things. So it might be very useful to have, but go ahead and choose that command search. And when you do that, this is the coolest thing because remember I told you that was remove polyline vertex that I use all the time? Maybe you don't even remember the whole name of the command, but you know that it had to do, it was remove something. So if you go in that search field and just start typing, let's say, I want to look at remove. So now these are all of the commands that say remove. So I might look at those and say, well, there's remove. No, that's not a row. But there's a remove point, so you would see at some point, at some stage, you're going to find that remove. Okay, now maybe it was about polyline. So if I did remove POL, oh, okay. So now, yeah, that was it. So there's my remove polyline vertex right here. All right, so look at what it tells you. Gives you the name all spelled out. It tells you the menu that it comes from, the parent menu. So it's on the edit menu. It gives you a submenu if it's on, which was on the remove polyline submenu. It tells you which modules are allowed to run that command. In this case, all the modules can run that command. And it tells you the typed keyboard command, so RMVERTEX, in case you're a typist and like to type. And it also tells you the toolbar that it is on. Okay. And if I've got more than one command that I'm looking at, as I can see all of these remove functions, you can see the different main menus, submenus, different modules. Here's survey and civil are the only ones that have these dealing with subdivision lots. Okay. And again, those are the names of the toolbars that are, that hold those commands. All right. And the menu locations, the submenus, if it's on a submenu on one of the pull rights. So this is just so helpful. And not only that, but let's say we had that remove, and we get it down to polyline, remove polyline vertex. So if I've got the command, if I select it, I can look at help about that command, or I can even run and it says, okay, select a polyline you want to remove a vertex from. Boom, there and this, and now pick a point to remove. So you can actually execute the command. So when I say use your 3D viewer, now you don't know where that's coming from. If you go to that command search, you might just type 3D. Oh, there's 3D viewer. That's not exact. That's 3D viewer file. But I know I was looking for something a little. There's 3D viewer model library, um, or 3D viewer to 3D image, 3D viewer block model, 3D viewer model library. I don't see. Uh-huh. That's interesting. I'm looking for actually. This is the command I'm looking for. It's called cube. Oh, okay. So they call it drawing viewer. Now there's a case of I'm looking for a 3D viewer, but 3D did not trigger it. So maybe if I had said instead viewer. So now there's my 3D views and 3D viewers. All right. So I would then choose my drawing viewer. And there's also a surface file viewer. And I look over here and I see that that is on, let's see, all modules. And it's which toolbars is it on? It's on more than one. So I'm going to open this up here and I see it's on takeoff, general. It's on surface for Carlson. So if I've got the takeoff product, they can also be on that toolbar as well. So here in the case, it's on more than one toolbar, so that helps me know where that is. So that surface toolbar lives up here under my screen, and I can always pick that and run it, okay? So, again, I would look at that, choosing here from my menu. There's the part of the drawing. Now remember, we built the surface called EG contours only, right? So I'm going to use the surface file viewer, and I'm going to look at that surface file. Again, I pulled that from the toolbar. That's the one that looks like the little pyramid, like a surface. Select the file, pop it up, and now here's the surface that it created, and it is displaying based on whatever these last settings I had, one of which is on the, when I'm looking at a surface, I can decide whether or not I want to see the contours. And I can even decide, what contour interval I want to use. There's 5-foot contours. Here's 1/10 of a foot contours. And it calculates those on the fly as you're looking at stuff. It reads the surface and draws the contours. Now, right down in here, remember those little flats, you see how that happened. Up in here, I've got this little ski jump, which is really, this is supposed to be a nice little loading dock. So I know I've got some issues. I look at my intersection, I don't see any of those curbs, but because the only thing it had to go on were these contours, right? So it's generally okay. It looks, sort of ish, of what it looks like. But a couple of things I want you to notice about it. We are missing some detail, but if I look at this here, let me turn on, I'm going to toggle this visibility off and look at some of these peripheral edges. You see these long skinny triangles? Again, we don't want those to form. We could let them form, and we could even do something like go to, now that we're in the surface viewer, I can choose this arrow. And let's say instead of doing this, we're going to remove triangles. And then I could just, start double clicking in here to try to get rid of some, and you got to catch one of the edges. There's another editor that you can use that's not in the viewer, that's easier. You could drag a line across it, get rid of them. So you could do all of that kind of stuff and get rid of those individually if you wanted. But the better approach is to not allow them to form in the first place. So we need to put a boundary around the data that says stop, go no further. This is that concept in our book that when we were talking about break lines, in the sense of these points, remember those lines are going to be formed, and that's going to keep the triangulation from going past that line. So we have one particular special case of these edge conditions, and that is, that's going to be our break line on the outside edge. That's our perimeter or our boundary. And we're going to say nothing is allowed to be outside of that line. So it has to be a closed polyline. Okay, so if we could somehow draw a polyline around all of our data to get these long skinny areas from forming, that would be helpful. Okay, so I'm going to exit my viewer. Now notice I've got rid of those. When I exit this, it's going to ask if I want to save the changes. I'm not going to save those. So we've got contours with triangles out here in the open space we don't want. We need to fix that. So how do you get a boundary placed around your data?
Shrink wrap the entities.
Yeah, that's the general approach, and that's the command is you would shrink wrap those entities. But now, what exactly is shrink wrapping doing for us? It's first of all building the um, boundary, and that's good. That's what we want. So there's a couple of things I want to point out on this shrink wrapping. First of all, it's on the draw menu, and it looks like a little birthday gift right there, shrink wrap. But there's a command right above it that says boundary polyline. Now that sounds suspiciously like what I would want to do. If I didn't remember the command shrink wrap entities, I was thinking about this. I'm like, oh, there it is. I need to draw a boundary polyline around my data. Well, boundary polyline is from the inside out, whereas shrink wrap is from the outside in. As an example, I'm going to just draw a couple of features over here off to the side. All right, so if I'll now switch to make these red and heavy. So now if I were to do boundary polyline instead, this is exactly the same. In fact, it's the part of the command that's part of the hatch command. This would be finding a hatch boundary. So you can either pick inside or you can choose, all the different areas. You can give it a layer name, et cetera, draw a 2D or a 3D. So I say, okay, I'm going to pick inside, and right there it is. That is from the inside out. So it's like you had, I had entered a finish. Let me erase last. I'll repeat that command, boundary polyline, and then I'll do it over here, for instance. So there. So it's as if you're standing in a bunch of walled areas and you had a spray can of paint in your hand and you just closed your eyes and sprayed around yourself in 360 degrees until you hit all the walls. Okay, here's another interior area up here. So what that will do is allow you to, find these boundaries, those boundary polylines to, maybe compute the area of what's in there, for instance, that kind of stuff. Same as if you would hatch that area. Okay. Now, shrink wrapping, on the other hand, works like this. Draw shrink wrap entities. And let's choose the option of bounded line work only in this little example. We'll say, okay, and we'll go like that. Okay. So it goes from the outside in, it wraps itself around everything that we are selecting. So if we said bounded line work only, now this is why I like this command, and so many people using Carlson know about that command, but only in the sense of drawing around line work that they're going to use to build a surface. They don't think about it in terms of, well, what if I needed the composite area of these two lines? Like maybe, this is phase one work, this is phase two, phase one concrete, phase two concrete, and this over here is topsoil replacement, whatever they might be. And I want to see how much concrete I'm going to use on my project. Well, instead of trying to take this polyline, see what the area is, take this polyline, see what the area is, figure out the area of the interior spot, subtract that from the total. If I use draw, shrink wrap, and use this to around my line work, say, okay, and I'm just going to look around those two things, then that, when I select it, it has an area right here, 35,205 square feet. just, 3/4 of an acre. Okay. So the ability to have that simply draw polylines, and remember, it can be 2D or 3D. So if I'm going to shrink wrap now to draw around this data, let's go and repeat that command. If I do the same thing, and if I leave it as bounded line work only, watch what happens. Okay. So it goes from the outside in, and it goes in, and if it sees a gap, if it can get into the data, it runs that gap until it hits something that it can't get inside of. And that's where it outlines all of those areas that are closed, and it can't get any further inside. But like in between all of these things, there's a route. If you think of that as a maze, there's a route. If you go into one of these gaps on the outside, you can wiggle your way around and get into all these areas until you get to right here. You can't go any further because that's closed all the way around. You can't get inside it. But you can get to that line because you can come in, this side and skip inside of this one. All right, so you get the idea of how that works, the difference between bounded line work and gaps. So if we repeat our shrink wrap polylines across gaps now is going to allow us to go across these open gaps out here on the edges, because what we're trying to do is outline these edges. Okay. So you would do that, and you would give this a distance of the maximum gap you would allow it to use. So if you got too big a gap, you're going to say, well, go inside till you find more data and then come back around. So anyway, you can leave that as however you like it. Now, here's the key, and this is what a lot of people don't understand what this does and what it's physically going on and why the prompt is so potentially confusing. It says perimeter reduction. It used to say in the older versions, perimeter triangle reductions, and that actually gave you more of a clue as to what's going on. But it says perimeter reduction, and you have these different levels. You've got no reduction. In other words, look at the perimeter and don't do any reduction. Or look at the perimeter and do low amount or a medium amount or a high amount. There's no real set value. They're just sort of qualitative judgment calls. And here's what they mean. If you go ahead and choose none, and we'll keep it as a 2D polyline, that's fine. And we'll say, okay, and select the points and line work you want to shrink wrap. I'm going to just type ALL, hit enter and enter. Well, that put a boundary around it, but what happened or what didn't happen is it didn't snug up inside those little slivered areas, right? So why not? What's going on with this? Well, what is going on with this is contained in that little setting of that perimeter reduction. So this is it with no reduction. I'll change that color here to keep them separate. Now I'm going to repeat the command, shrink wrap polylines across gaps, and I'm going to change from the no reduction to the high reduction. I'm going to say, okay. And it's going to ask me to select everything. I'm going to select everything here now. Be careful because I've still got this outside edge. I need to remove that one from my selection set. So I can either hold the shift key down and click, or I can type R to remove and pick it. So now I've removed it. I hit enter to finish. And now there's that one. And this one, let's make it blue to give you some contrast. So you can see how it has actually gone into the gaps here and then some. And look up here around here, it goes up here and jumps in, comes back out and jumps in, comes back out and jumps in, because we've told it to do a high level of removal around the edges. Now, what is it removing exactly? And this is what people aren't aware of is happening. When you do a shrink wrap polylines, and Carlson was the only company, the only software company that had this command for a long time. Civil 3D has a version of it, maybe even Map 3D, I'm not sure. Um, but theirs doesn't work. It's really buggy and it crashes the system sometimes and just sometimes will just fail outright. But here's how Carlson accomplishes this fact or this result. When you say shrink wrap entities, prompts you to select everything so it does it. And so what it does in the background, and it does this really, really fast, is it actually triangulates that data. It builds a little surface off in memory. And that surface, if you remember when we looked at our surface viewer, we had all of those long, skinny triangles out there on those edges or around the perimeter. So that's what it's asking you was how aggressively should I reduce those perimeter triangles? So I'm going to take a pass. If I see a triangle around the perimeter and it's longer than the average triangle somewhere else, I'm going to throw it away. How aggressive do you want me to be? In the case of none, that means don't do any of that reduction. Keep what would normally be included. And so it takes everything out there where that could be potentially generated. If I say hi, I'm going to say keep doing multiple passes around that little uh, surface that you built in memory and keep throwing away triangles until you finally, exhaust the algorithm. And so that's the difference. Now, if I do this one more time and change it from high, say down to low, and we'll take all. I'm going to type R to remove. I'm going to remove, I'll click the yellow one and I'm going to click the blue one up here. And so now this one will make it red. And so you can see the differences now. The yellow was none, the blue was high, the red was low, okay? Medium would obviously be about somewhere in between. You can also affect this by changing that maximum allowable gap. But what are you left with at the end of the day? I'm going to select that blue one and that yellow one and get rid of them. So what are you left with after you run that command? If you select that item, I look up here and my properties and I see, well, that's nothing more than a polyline, right? And you can do anything with that you can do with a polyline. So like right here's a case where it didn't really get enough in here. I want to, trim that up a little bit. So you could, I'm going to select the polyline. I'm going to hover the mouse over that midpoint grip, and I'm going to allow the menu to pop up. I'm going to say convert to arc, and then I'm going to just scooch that up in here like so. Yeah, this makes a nice little rounded place. I could come over here and say, well, this is cutting in a little too far. I want to pull these vertices up, or better yet, maybe I'll just hover and remove vertex. I can take these things out and sort of straighten this up a little bit, give it a little bit more uh, freedom as it goes around, just in case. Okay. That's another great incidence of instead of hover, remove, hover, remove, hover, remove, or running the p-edit command, a nice Carlson command up here on my toolbar is to remove polyline vertex. So I choose that, select my polyline. I get the little blips to show me where they are. They're just temporary. And I don't have to snap or anything. It's just whichever ones I'm closest to are the ones that are going to be removed. And I don't have to do them in order or any of that kind of stuff. but I can sort of step my way around it. So that looks good. Maybe I'll let that one come out and relax a little bit, maybe a couple here. If you zoom out, the blips go away until you start doing it up here again. So let's see, maybe here I'm going to take out, some of these little inside lower points. Again, I'm just clicking near, and the one that I'm nearest to is the one that's going to go away. And so I'm using that as a tool then to reshape this polyline. Okay. Now, does any of that stuff matter in terms of building the surface? And the answer is no. If I were my boss, I would fire me for wasting a bunch of time trying to prettify this little polyline around here necessarily, because maybe over here's where I'm working. I don't really care what's going on out here other than I don't need, if I've got data way out here, I don't need all that data. I can just restrict it to what I'm doing. Okay. So here's the typical workflow when you're building these surfaces is that you have that choice under surface, triangulate and contour is to right here use inclusion and exclusion areas. And if you have that on, it will prompt you to, instead of just select the data to triangulate, it's going to say select entities, but it's going to say above that, select all your inclusion perimeter polylines. And then it will ask you to select your exclusion polylines, examples of which might be a building footprint or a pond outline, any of that kind of stuff. All right. So this is the way we used to have to do it. We used to have to create our polylines, get them there, and then when we model the data, we pick it, we select all this kind of stuff. The command now has built into it, if you don't do that, it now will automatically shrink wrap the data and ask you for the perimeter reduction, just like in draw shrink wrap, none, low, medium, high. And so you could set that, put it down to low or put it to medium. You can see what it needs to be. And let's say if I choose, low, then I've got a setup button that now, if I have anything other than none, I'll get this setup button. So I can choose that. I can choose whether or not to draw it. So I don't even have to draw it. It's going to use it and compute it and then just throw it away. And I could switch to a 2D. I could give it a layer name that it's going to be on. Now, the reason I like to do this, even if I don't create, I usually create mine manually. But if I don't, and if I'm using this, I will always draw it because I want to take a look at it to make sure it doesn't have any major omissions, that I may not notice right away. Okay. So I generally draw mine and then pick the data itself. So if I now use this and choose OK, yeah, it's okay to overwrite the data. Now it says select entities. Well, don't get excited and just start grabbing everything. Read the line above. It says select the inclusion perimeter polylines, can be plural. So I've got that selected. It tells me I've got one entity in the set. It still says select entities. I keep selecting. I'm through selecting inclusion polylines. I hit enter. All right, select entities. And let me tell you, it took me a week of running this command before I got used to this because I kept wanting to see my surfaces and I kept trying to triangulate the data, but it wasn't asking for that yet. It does say select entities, but it says select the exclusion perimeter polylines. Again, things like building outlines or pond outlines, things like that, or enter for none. So I'm going to say enter for none. And now it still says select entities. And this time now we're finally back to the select the points and the break lines to triangulate. Oh, finally. Now I can grab everything and select it and hit go. Again, no errors. I look at my surface 3D viewer. There's now that surface. And this time, instead of these long, skinny triangles over here in these edges, down here and over here, you can see they have now been completely eliminated. So that allowed that to happen. Now, likewise, if you did something like so, triangulate and contour. Whoops. Sorry, wrong command. Triangulate contour. Deal, yes, overwrite it. Select my inclusion. Well, maybe I've got, phase boundaries here. Phase 1, phase 2. I'm done with that. No exclusions. Data to triangulate everything. Boom, boom, boom. There it goes. I look at my surface and what do I see? Well, that is a single surface file, but it is limited to, what was bounded. So if I go out here and grab all of this data and now come back here, you can see how that's, now that line, let me get this, ignore zero, turn back on. So it took those inclusion areas, even though all of this data was calculated, you can see what it's done is it limits what is done there. Now, there's one last little distinction to be aware of. When you triangulate and contour, and we say do use the inclusion exclusion areas because I've got closed polylines, the boundary method. And right now is you can either trim those triangles at those edges, or you can remove the entire triangle instead of trimming it. Okay, so lopping it off. So right now that's usually your cleaner, nicer function. But if you choose to remove the crossing edges, say okay to overwrite. I won't get those interior ones. I'll just get that outside one now. But then you should be able to see the difference in the triangles. So you see how up here it didn't follow that nice smooth little arc because these triangles actually, let me show you that what this might be the easiest way to do it. Oh, it's going to be hard to see because of the perspective. Let's see. Let's get it down here. Well, anyway, if I zoom in, I see that's a nice smooth arc there. But so the triangles that were spanning that, now let me go back to here. So across here, they might have spanned it, but it threw away the entire triangle that crossed it instead of trimming it. So when you did the trim boundary, that was nice and smooth, witnessed by running the command again and changing that to trim the edge. Okay, to overwrite, grab my boundary and all the data and view it. And so now you can see they're back. So it goes up and meets that perimeter of that polyline. And so these were all, and the reason there's so many of them in here is because remember, they all made those long skinny triangles through here. Those are the triangles that now got clipped. They got trimmed instead of removed. When it said removed, all those triangles formed and they just went completely away. Excuse me. So now, instead, it goes up and makes a nice even clip. But we still have some issues here. We've got, see this little sort of messed up over here, kind of looking stuff. And we talked about some of those and how those brake lines are going to help us to fix that. So that was our contours only. We had some other areas where we had, we had those little stair steps running down the edges. And what's the one that will fix that is the minimized flats, if you remember. Um, bear with me, sorry. So what else could we do if we had a situation like this and the only data we had were these contours? And I've actually done this in my younger foolish days, is I've actually sat down with my polyline creation tools and I may have laid in polylines, drawn in my brake lines. If I get a situation like that and I've got a bunch of these things here that I'm getting problems with, I'll actually draw those brake lines and put them into my data. And now they have to be 3D. So I usually found it easier to draw them as 2D and then go to my 3D data menu and choose 2D to 3D by screen entities. And so I would tell it anything that it crosses that has elevation, assume that elevation and use that to go with. That's called draping. Okay. So, but as you may well imagine, taking the time and effort to draw all of those brake lines is really counterproductive. That doesn't give us the efficiencies that we need from the computer. So, what are some of the other options? Again, you already, we've talked about a bunch of these. We've drawn our shrink wrap, um, or we let the command create the shrink wrap for us, which you can do, and choose not to draw it, and it just does it in memory. So all of that stuff could work well. Now, if you remember when I drew those giant rectangles here in the middle, I didn't use shrink wrap for that. And I could just say, draw a, draw a 2D polyline, and I could just, let me turn my snapping off from it. I can just go here like this. And just manually draw it. Okay, I don't have to, it doesn't have to be shrink wrapped. It can be done any way you choose. But if you do shrink wrap, it is more guaranteed to snug up against the edges. Sometimes it's a little too far, a little too tight. But any way that you can do that, because at the end result of the shrink wrap polylines command is a polyline, just as if you have drawn it. Okay, so any way that you can do that is absolutely fine. Now, let's do this instead. Let's go back and we're going to restore the layers that we've isolated layers, so we're going to restore layers. So on the view menu, we had isolate layers, restore layers is right underneath it. Now, there's another couple of commands here called freeze layer by pick or by selection, and then thaw layer. So freeze and thaw goes together, isolate and restore goes together. I've isolated my layers. I'm not going to restore the layers, and it's going to turn everything back on. Now, I want to compare those contours only with the surface I'm going to get by using the brake lines and the points. Remember, we've got those points And you can see them with these point utility, or not point utilities, but settings. IntelliCAD settings, point style. I'm going to switch them to these X's and make these, say 1.5 feet. So now I can see the points. So now I'm going to go back to, I'll use my toolbar now. I want to isolate. So isolate and restore are right there. And then I've got freeze, freeze, thaw. So those are the ones that go together. So I'm going to isolate and I'm going to pick one of the white lines and one of those pink dots. So now, ooh, let me restore that. I went to also isolate the boundary. So I'm going to isolate. I'll just do a crossing like this and pick that red one too. There we go, because I'm going to use that as my, I could use that. I've got some data out. This represents something to tell you about. The company that did this mapping, the aerial mapping company, the photogrammetry company, they have a practice of, let me come back here and set my point style back to the dot here. But their practice is to compile out to the edges of the photography and then go in 50 feet and trim off the contours. They go all the way out to the edges, but then they come inside and trim the edges to what, so if the client says he needs, this area, they outline that, they extend it 50 feet all the way around it, compile everything out there, and then use the 50-foot offset to trim back what they generated. And that gets rid of these little edge issues that they might encounter, and because they're on the edge of their visual model. That's why this line is different. So if I shrink wrap this one now, I'm going to draw a shrink wrap entities. And again, I'll go across gaps, use 2D, perimeter reduction, I'll leave set to none or low. And I'll say, okay. And I'm going to grab this data here. And there is the shrink wrap on that. I will tuck that in just a little bit there. Now, I'm not going to bother to go up here and clean these edges up here. Uh, you could do that if you were a real stickler. All right, so now I've got this data. If I triangulate and contour once again, and this time I'm going to change file names. So I'm going to select and choose EG instead of contours only. I'm going to say BKLN and PTS. So break lines and points. Keep everything else the same. Say okay. And now ask for an inclusion. I'll select that outside boundary I just did with shrink wrap. No further inclusions. No exclusions, and now selecting everything, and I can take everything and I don't have to worry about removing this because why? It's a 2D polyline, it's zero elevation, and I said to ignore zeros. So now this comes up. Now this illustrates that entire point, is that some people consider it more successful to have built the surface from the contours because it built it and it did not give us any errors. This ran and it's, oh, hey, you've got some errors here because the photogrammetry company maybe got in a hurry. They got a couple of places where there's some issues. I've got 3 crossings. I've got 2 vertical edges. And if I open these up, you can see the relative difference in elevation. Now, this being the case, again, you can set your settings, and these are your tolerance values that you want to set to, if it's lower than that, don't bother reporting. And so I'm going to look at this and see if I need to fix anything. And I would look at these vertical edges. I'm less than half a tenth here, and I'm just barely over a hundredth here. I may decide not to even bother with those. Because what happens when it does this? It does go ahead and build the surface, but it chooses one of the elevations to use. And I don't know, what governs which one it chooses. Does it take the one that was drawn last? I don't have any idea. Um, but this is so trivial here, I may just ignore the vertical edges. Well, I've got one here that's actually 3/10 of a foot difference. I've got these two that are very close to being not much. I may ignore them, but let's take a look at these individually. So I'm going to hit the zoom 2. That's going to put it in the center, and I've got my little arrow marker showing. And now I'm going to zoom in. And what this is a head wall where they compiled the top edge and the footprint, the bottom edge of the head wall. And they got in a hurry and they allowed it to cross over because, they did one edge first and then the other edge first, and they weren't paying close enough attention. So I'm going to now exit, and I've got some other places. Like if I look at this, I've got a place, looks like that crosses in, looks like it's not, oh crap, all right, so there's a couple of other places where it crosses. Well, I've got some issues going on here. There we go. Where they come on like right in here. If you zoom in down here, you might see this road edge. That one doesn't cross, so that one's fine. But there's another one that's up. Oh, I don't know, like right in here maybe, and you'll see. Yeah, see right there where it crosses. And the way I would fix that is I would just simply break. I would just use a standard CAD break command, and I would just say, trim that back like that so it no longer crosses. All right, so uh but what's happened here with this head wall? Let's make one of these red. And let's make the other one green so you can see them and what has happened with it. So if I take a look at these two items, I can see that, yeah, see how it crosses? It crosses right up here and it crosses again right there. And then it crosses here. So it's found those particular places. And so let's look at the relative elevations. So this elevation has a low point up here. I'm hovering in the grip, looking down here in my status bar, and I see the elevation is 13.13. If I look at the green one, I see that's at 13.04. So that's lower than the red one. I come up here and look at this corner. That red corner is 13.93. This green corner is 13.63. So the red one is the top. That's supposed to be the top of the head wall. Now, this is a culvert that goes underneath here. Here's the end wall. So the culvert, or maybe I've got them backwards. Maybe this is the head wall and that's the end wall. I think that's the case. So the pipe goes under the ground. So this to be a vertical surface, the red one is the tall one. Let me double check here. This green one is at 1371. This one is at 1366. Oh, they've actually, and then it goes all the way down here to 1315. So they've actually sort of crisscrossed up in the air anyway. So what you need to do is make sure you don't have a vertical surface. You want to lean back so the footprint, we're going to call the green one the footprint. What's really probably actually happened is that the red one is the footprint out here, and at some point it switches to be the green one. So they sort of really need to recompile this. We don't have that luxury yet, so let's just make sure they're not crossing and they're not going to be vertical. So I'm just going to grab this grip on this red line and just stick it out here outside. so that I no longer cross. And then maybe all right, so that doesn't cross. So that would now be, and I've got those selected. I look at those in my 3D view. And I see that, okay, so that's going to be the case. Now there you can see they actually, so the top is actually going to dig down into the ground a little bit right in there, but they won't cross. So they'll form the surface without error this time. So let's go back and redo triangulate and contour. So I'll triangulate and contour, leave everything else exactly like it was. I'll just say, okay, and confirm to overwrite. I select my inclusion, no other inclusions, no exclusions, and grab my data. Off it goes. Now I still have, I've got crossing break line said it filtered 17 out because they were below my tolerance settings here. So those I don't care about. I still have these vertical edges, so if I choose, there's a vertical edge where it ended up, and I would need to sort of break that off, to trim that off. Again, it's a trivial amount. Here's a case where I've got a vertical edge. Again, I've got, this line is at 1300.81, whereas this line is at 1300.80. Okay, so I could simply take that and then snap it to that endpoint, and now they're both sitting at 1300.80, so that would fix that one. So any way that you can repair those little things, again, I'm not going to worry about those. I'm good with this. I'll say exit. And remember, the file actually got built. It just pointed out the errors. So now let's look at that surface. So there's my break line and points. Now notice the difference. When I look at this one, I'm going to go to my model tab. I'm going to load up the other surface, which was my contours only. And then I'm going to open that little surface and I'm going to turn off my contours only for right now. And if I look at these, look down here at these road edges, you see how nice and crisp that edge is there. And I can also see, go back to my view control and sort of give you some shadows. You see that is a nice little flat, little raised area. Look up here in the intersection. I've got these really nicely well-defined curb edges here. And if I go back, I want to look down at this area right in here. See that retaining wall and that curb? Same thing over here. I've got this retaining wall that's built up in this curb, and I've got this nice little retaining wall along our building footprint right in here. Now compare that to this surface. See the difference? There it is with that. There it is with that one. So the red one is or the brown one is the contours only, and it matched for the most part in places, but look at all these little, these little dumped in flat areas, along our road. Sorry, getting seasick here. So I've got these, uh, these little flat areas in here that would be a problem. And if I, used this to try to calculate my storm drainage, for instance, my time of concentration is going to be off. My flow lines are not going to be nice and smooth. Whereas if I use this one, everything's going to be nicely modeled. And I get some nice, precise edges that I can go with. So the same thing applies if I'm doing this as a design instead of just trying to model existing ground. When I design these parking lots, I'm not going to worry about trying to draw contours across my parking lot. I'm going to set my elevations along these edges And then I'm going to let the computer tell me where the contours go. Okay, so once I get these edges and I see that they're nice and well defined, then I'm going to, um, you know, take that approach. I'm I'm using an edge design approach versus a contour design approach. And that was Corey. I know you've got that, and you'll probably be dealing with that some because the guy that you've got, working with you, his design approach is the opposite. He'll draw in contours. Now it accomplishes the same type of thing, but when you design with these edges, you can now take that design and stick it on a thumb drive, put it on a dozer, and have it the GPS, drive the dozer to create these nice crisp edges.
Yeah, I
Okay.
think I want to prefer to. I need to learn that technique, I guess, how to set the elevations and then do slopes and things like that.
Yeah, and that's all you do is you just when you lay these lines in, you're going to create those surfaces. So when we come back after lunch, we're going to actually put a little building pad up here now, and we'll turn it into a parking lot, and I'll show you that approach and how we use those for our grading. Okay,
Yeah.
and so that'll give you that as a technique. Now, one last thing to illustrate here, and you may not be able to do this. I'm going to restore by layers now, and now I'm going to. Uh, I'm not going to build any more surfaces, so I'm going to just select. I'll just select those and get rid of those. I'm now going to freeze by pick, again on the view menu or on the toolbar. So freeze by pick, and I'm going to freeze off those break lines, and I'm going to freeze now by selection. And I'll grab some of these points in here if I can. Okay, I've got some points. So now I've frozen the points and the break lines, and this is really more of like the finished drawing. And I'll use that as my design base. So I'm going to hit save here now just to save my work. But what I wanted to show you is that there are two modules in addition that you may or may not have. If you have the Civil Suite, which I think, William, you may have, then
Yeah.
you also have a GIS module. And some people get this module for just this reason. And I'm going to switch. I'm going to go to settings, Carlson menus, GIS menu. And this is, besides all the GIS stuff it does this. If I go to, well, first of all, I need to make sure, I'm going to go back to settings, drawing setup. And I'm going to make sure down here my projection, right now it says none. So I'm going to pull this down and choose a predefined, user defined. And I'm going to define the projection and make sure I'm going to use this NAD 83 Pennsylvania South. So North American data of 1983, the 2011 adjustment, Pennsylvania South. If you don't have that in your list, hit your add predefined, search for Pennsylvania, add that to your list and create that Pennsylvania South. And then set it to that, make sure it shows here, and then say okay. Now, once you have told it what position you're in, and if you are truly in that coordinate space, and we are, we look at down here in my status line, you see those coordinates are in the millions. So now if I go to the image command on the GIS module, I can place these images, and one of which is a Google Earth image. Now, these are not all that exact, and I'll show you, I'm doing that for a purpose. So I'm going to say place a Google Earth image. Now it comes up and says select an output file. So it's going to actually create a drawing or an image file. I'm just going to call it site location. Now I will tell you that if you do this multiple times, if you do one and you don't like it and you go back and do it again, you need to change that to a different name each time, because every time you run it, if you keep the same name, it shifts it horizontally. That's a little bit of a bug. But for right now, this will work fine. We'll say save. And it says, well, do you want to pick from the screen or use a map, which would pop up an internet map and let you choose from that, but we don't. We're going to just say from the screen. And then we're going to zoom down here and just grab, the lower left corner. go up to the upper right corner. And depending on how big you make it, is going to tell you whether or not you can use low, medium, or high resolution. So sometimes if it's too big, there is no high resolution imagery available, so it defaults down to medium. So I'm going to set this up to high. I'm going to use a map type of aerial, hybrid. Hybrid will label the roads and stuff like that. And then place in the background, I'm going to say okay. And it's going to now go out and grab the Google imagery from Google Earth and place it under our drawing. Now there it is. It's nice and bright. It sort of overwhelms it. So I'm going to select that image on the edge and I'm going to go over here where it says fade and I'm going to put that at 50%. So it now tones it down a little bit. Now I can use that and I can zoom in down here and I can see things like I've got, well, let me change that fade to a little more than 50. Let's make it say 65. Okay, so now let's look at these curb lines. You see how they don't really line up. Here's you see how they're close, but they're not exact. Now my drawing information, those are survey accurate. Those are survey grade accurate, but the imagery is a little bit off. Okay. But what this will do is it just sort of confirms, that you're in the area and you might see a feature that you might want to, draw into it or whatever. But because it's not exact, you know, um, and if you wanted to make it more exact, you can do that. And that's available on this other menu, another module. So if I go to settings, Carlson menus, now you may not have this on yours, but it's this CADNet menu. And I think, Corey, you have that one at least.
Yeah, I don't have the GIS, but to do the
Well,
aerial imagery to overlay, that you have to have the GIS module.
to be able to put a Google image on there directly from that command. And now you can get images that have world files and all that, and they'll overlay exactly because they're ortho rectified. And you can do that just by, um, just you can use the standard CAD command to do that as long as you know the lower left corner of the lower left pixel, whatever that coordinate is, and you have a rotation value. So there's ways of doing it without the GIS module, but that just makes it a real quick way of doing it. But anyway, when you switch to CADNet, we have a command on the raster menu now called rubber sheeting. And right here it is rubber sheet. And what that's going to do is it's going to ask us for a series of points. I'm going to go down here and turn off my snapping. So it's going to ask us for a series of points. We're going to tell it a point in the photograph and locate a point in the drawing where it's supposed to line up. So I'll go to this and choose rubber sheet, and it's however many we want to use. So if I go up here where I saw those misses, I'm going to say, well, right there's my point in my drawing. So I'm going to grab the back of my curb there, and it's supposed to be up here. And I'll go over here to this side and say, well, right there's that back of curb, and it's going to go up to here. And I might, find a few sharp corners that I can see and identify. Maybe come over to here and I've got some inlet. You can see that little dark area. That's the actual inlet for that. So I'm going to just sort of get in the center of the inlet and go up here. I had a couple of other identifiable things in here. Let's see, there's some more inlets. I can't really see them in the imagery. Um, let's find some more parking or curb edges. Here, for instance, is, there's a curb that should go up to there. And let's maybe get something down in this other corner. So I want to sort of spread it out along, so I get, across the site. Those aren't really all that readily identifiable. Let me see. here's a place, say from here needs to come up to here, maybe here, it goes up to there. So I'm using these to warp this image into its proper position. You can see how it misses right in here, for instance. Now, I'm not going to set a control point there because I can't really, here's a place here, maybe from here goes up to here. So see, it just keeps asking me. I now have 7 control points in there, and it's going to do an affine transformation here now. When I hit enter to finish my selection, it's going to actually warp that image and shift it into place. So now if I zoom in here, you see how tight that fits my curbs now? And if I go over here and look at that inlet, you see that's right smack in the middle of where that inlet is. And maybe come down, look at these edges. Now I come in, I've got a nice fit on the parking in there. Down here's some more parking. And here you see the image around my curb lines. They fit here. Now here's the actual, there's some spillage here. I think the image was out of date a little bit, but you get the idea. Where was another one was along this curb edge up here where I didn't put any of those points. Remember how that little shift was right in here? I didn't put anything in there because all these others took care of warping everything to fit. So it's what they call rubber sheeting. So you're going to give it those different points and it's going to use those as control points. And now you can see this feature, that's a light pole or something. Everything now lines up nicely. Okay, now your building tops, keep in mind these buildings that you see, these outlines, are actually the bottom of the building wall on the ground. And you're seeing in the image, you're seeing the actual roof. Now, in this case, it looks pretty exact, but if you had a real tall building, you would see that shifted a little bit because when they're looking at it in 3D and they put that point exactly where that wall goes into the ground, but when you're looking at it in the image, you're looking at what's called vertical displacement or radial displacement, and you'll see those tops are sort of shifted away from where the bottom is. So, but it still, puts these things down where they're supposed to be. Here's, yeah, see right in here how that doesn't line up there, but the actual bottom of the building is along that line. Okay, so, but that's those two modules. GIS lets you bring the image in. CADNet lets you shift the raster and rubber sheet it into a real tight fit in case you needed that for any particular reason. Okay, we don't always, and it may not even be something that you need to worry about, but it might be something that, hey, that's really kind of useful. I might want to, incorporate that into my design work. Now, if I look at I'm going to thaw my layers. I'm going to get those brake lines put back on. So now you can see the brake lines, they all line up, all along those wall edges. There's my retaining wall along that loading dock. Okay, so you get the idea. So that just gives us something that we can use to help us, when we're, particularly if we're designing, we may look at something here. Now, there's another case where should have put in that little extra control point. But again, it's a pretty good fit. And so this gives us extra information that we might not have in our survey data that we can see. Like right in here's a bunch of whatever that is. Those are called storm manholes. And so you can see that this was a structure at one point. Maybe they've torn it down and and there's manholes in there. So you could either confirm that something new has been built or something that was there is no longer there. You know, anything that you would find the imagery useful for that helps you to do that. As long as you're in state plane, some kind of definable uh, coordinate system. And even though Google uses, for the most part, a Mercator UTM projection, we're in a Lambert conformal projection for Pennsylvania South. And so that software, when I bring that in, it's actually doing a transformation on that imagery and shifting it from external reference file changed. Oh, okay. That's because I changed the actual imagery. Um, so what it does is it actually reprojects. It takes every one of those pixels and it recalculates its new location and then and that's in its original, say, UTM Mercator projection, and it does the transformation on that pixel by pixel and shifts it into my projection of Lambert conformal, North American datum 1983, Pennsylvania South zone, and it brings all that stuff in so everything lines up where it's supposed to be. That's, uh, some pretty powerful stuff that we used to have to, we had to do some special kind of work to make it happen in the past. So that gives you a sense of a couple of things that you might want to add to your bag of tricks. If not, you can certainly get by without it. But, as food for thought. So I'm going to shift back to civil. I'll save my drawing. And we're coming up on a quarter after, so I'll declare lunch and we will come back at a quarter after. Um, and we'll do a little design pad and look about, how to set edges and check our designs as we work through the rest of this grading example. Okay, any questions on this to this point?
So that last thing where you were like removing, like moving your image overlay, that was in CADNet or that's GIS?
No, that was CADNet,
Okay.
and
And that's a separate module?
it is a separate module. So I've now switched to that, and it has a raster menu.
Okay.
And a lot of people use CADNet to bring in PDF files and all that, but you can also bring in PDF files without it. But it has some extra tools in here, and it's got a BIM um, coordination menu set, but it's here called Rubber Sheet, and it has to do with the raster image. And so you choose that, and it prompts you to select the image that you want to change, which I did. And then I gave it the from this point to that point, from this point to that point. I just went around my image and found some defining corners. And you don't want to just do 1 point or 2 points up in one spot. You want to spread the wealth out so that it gets a nice site-wide adjustment so it can, make a better fit. Okay.
Gotcha.
So that's about it. I'll see everybody back at a quarter till. I will stop the share. I will pause the recording. So, all right. So after we had a good lunch and a rest, let's finish up our work here. So we're going to model a little parking lot. So one of the first stages that we really want to do is to just draw the outline. And we're going to typically draw that kind of thing in 2 dimensions first. We're going to do, because that way, if we can put curves around the corners and put islands and things like that in it, then we will elevate those edges to make um, our pad, our grading design, and then tie all that stuff together. So if we just draw a an outline of a parking lot. I'm going to just draw a rectangle. So I'm just going to, first of all, I'm going to go to my layer control and I'm going to make a new layer called C dash site dash PKLOT dash curb. And I'll make that this cyan color. I'll give it a little bit of weight so you can see it better on the screen. And I'll make that current. Okay, now I'm going to go to my draw menu and I'm going to draw a 2D polyline and I'm going to check to use my current drawing properties. Okay. And actually no, I'm gonna cancel that and just draw a rectangle. So I just want to draw a rectangle that's about say that big. Let me change that to by layer. And I'll just sort of put it in right in here. Let's see, I'm going to move that from that corner to that corner. Now I want to line it up so it's parallel to that line. In fact, I don't even have to move it there. I can put it here. If I want to line this up to be parallel to that side, I'm going to go to my edit menu and I'm going to choose align. I'm going to do a 2D align. So it's not going to look at elevations at all. So I'm going to align my parking lot. Hit enter. It says, give me a source point where I'm going to say, well, take that point and I want that to equal that point. And then it wants to know a second point. So I'm going to go get this endpoint and I'm going to have it equal this endpoint. And now it's going to ask me, do you want to scale based on those line points? And what that would do is it would take this, move it and rotate it up here and shrink it down so that that edge is the same length as this edge. But we're not going to scale it. We're just going to use the move and rotate. So I'll say no, it's now lined up there. And now I'm going to select it and just grab the grip and move it back over here a little bit out of the way. All right. So now we're parallel to our little parking edge over here.
Hey, can you show me that one more time?
Yeah.
Sorry.
All right. So I've drawn my little parking lot.
Yeah.
The rectangle and it's square to the screen, but I want to line it up square to this edge. So I'm going to go to edit. Now you can do this with standard CAD tools where you would say, select it, move it, and move that point up to that corner, and then you would rotate it. You would rotate it based on that corner to the blue corner, and then turn it into that corner. That does the same thing, but this is a little bit easier to do, I think. If you go to edit and align, it's a 2D align. Otherwise, standard align will recognize elevations. We're still in 2D right now. So I'm going to just select my pad. I'll hit enter to finish the selection. And it wants to know my first source point. So I'm going to grab, see how I'm snapping to that endpoint right there? So I'm grabbing that endpoint and I'm going to make it go to that endpoint up there. It wants to know a second point now. So I need 2 points. So I'm going to grab that point and I'm going to make it go to this endpoint down here. And it asked me, do you want to scale the object? That means this parking lot. Scale the objects based on these aligned points. If I said yes, it would pick this up, move this corner to this corner, rotate it to match that bearing, and then scale it down so that this corner is exactly the same as that corner. Well, I don't want to scale it. All I want to do is do the alignment. So I'm going to say no to that question.
All right, got it.
Okay. And now once that's in place, I'm going to select it again and just move it back over here where I'm going to be doing my work. I'm going to say coming like right off of this. There's a little access into here. Maybe it's a little too close. Let's move it, say back like this a bit more, maybe like that. There we go. All right. So we have that. Now let's say we're going to basically extend this little drive area here so it goes straight across into our parking lot here. And let's see, let's maybe move this up just a little bit, sort of match this edge into this edge. Not exactly, but and then we're going to obviously get rid of this little island here in the middle once we do our construction. Now, so let's design our edge. We're going to be coming off of this road, but basically the extension of this existing entrance that goes into this parking lot. So I'm going to take a line, I'm going to draw a 2D polyline. And I'm going to just sort of go from that midpoint to that midpoint there. And that's going to be, let's see what, it's not exactly perpendicular. Let me move that. I'll snap perpendicular to that. And I'll read that it has a distance. See how wide is that? Length is 23.67 feet. So we're going to make a 24-foot. And I just did that to measure that width. So we're going to make a 24-foot wide edge. So I'm going to go to draw 2D polyline. And I'm going to say, okay. And I'm going to start like right here. And I want to go perpendicular to this edge over here. So I need to choose that perpendicular snap. It's up here on the toolbar, or you can hold the shift key down and right click the mouse and choose perpendicular if it's not set already. And I'll snap to that. Now there's the edge. That's basically extending that edge perpendicular here. I want it to be 24 feet wide. So how do I make this 24 feet off of that? I'm going to offset this 24 feet. So you can go to edit, offset, standard offset, specify an offset distance or go through a point or erase or layer. I'm going to say 24. So that's my standard width. I'm going to say from here and pick the side to go to. It's going to be at this side here. Now, that's not going to go over here and connect here. It's going to connect to this edge. So I'm going to select that edge and then right click and choose trim, and I'll trim off these two edges here. So that's going to be that. Now I'm going to want to put in a little radius curve in here, like about a 15-foot radius or maybe 20-foot radius. We'll see what we can get. And we'll do one in there, and we'll also do one. We're not going to do one in here. We're going to come in here and put an island in so that, that will serve as that function on the inside of our lot. All right, so how do we put this little curve in here? There's several ways of doing that. Is you could, break this line and then fill it these two lines and fill it those two lines. But I'm not going to, I really just want to put a curve that's tangent to both of these segments here. So the way you're going to do that is go to draw. Now you can do it as an arc, and you'd have to know like where it starts and where it stops, or at two tangents and a radius. That's the one we're looking for, because I'm going to go tangent to two edges and specify a radius. So I'll choose that. And it asks me for the radius that I want. Okay, so let's try a 25-footer, see how big that looks. Now it says pick a point on the first tangent line, which would be here, and pick a point on the second tangent line, which would be, here. So that now creates that, except you see what happened? I'm going to undo that. What happened was is it did all that and trimmed it. So let me see if I can repeat that command if I've got some options. No. All right. I don't want to get rid of this other thing. So let's maybe I'll use these to trim with. So I'll select those two and trim, and I'll get rid of that edge. Now when I trim these, it'll take care of those correctly. All right, so now back to draw arc, two tangents and a radius. 25 feet. I'll select this one and then this one. And then I'm going to repeat the command and do it on the other side. This one and this one. Oops. First line, second line. There we go. So now both of those curves are a 25-foot radius, even though this one's much larger. But if I look at that curve information, I go to Inquiry, Drawing Inspector on, look at my dialogues. I'm going to take off these layer names and polyline data. I'm just going to look at curve data. And when I hover over that, I see that that has a radius of 25. This has, oh, that's got a bad radius. I must have missed that. So I'm going to turn off my drawing inspector. And I'm now going to repeat that command again. Draw, arc, two tangents, radius. This time, I don't know why it somehow I gave it the wrong number there. So 25 feet. Now I'll select this and this. Must be contiguous. Okay. So let's see if we can. Guess what we need to do is erase that. So I'll edit polyline utilities, remove polyline arcs. So I'm going to take this arc out. Crap. Hold on. Let's try that again. Edit polyline utilities, remove polyline segment. Let's see if it recognizes. There we go. So that now should give us a chance to work. Draw, arc, two tangents, radius, 25 feet. Select the first guy and the second guy. All right, one more time.
Yeah, when I just did mine, it did something similar on the bottom one.
Here, and
It kind of trimmed it after it
you
cut a
gotta
radius.
you gotta pick back behind it. When you pick up here, it trimmed that one. So I picked back behind where it's going to hit. All right, so now I've got my little entrance there. And I'm going to use that now I'll select these two again, and I'm going to right click and choose trim, and I'll choose this to trim that out. Okay, so now I've got those outlined edges here are taken care of. So how do we set the elevations of this feature here? And the way we do that, now let me see if I may have screwed this up. Yeah, see, that was originally a 2D polyline and now, or originally a 3D polyline, and it turned the whole thing into a 2D polyline. Oh no, it's still 2D because if I look at this one, yeah, it's still 2D. All right, so we're in good shape. Now, what we're going to need to do is we're going to need to lay this feature in on our surface. Same thing with this feature up here, but then we're going to have it stop, and then wherever these curves start, we're going to go from the existing ground, then we'll come up to where this one is going to get set. Okay, so what we need to do is separate this feature that's now all connected, but I need to separate the arc from the actual tangent part of it. So I need to go to Edit, Break, and I want to break at a selected point. So now it says select the line arc or polyline at the breakpoint. So I'm going to pick over here, and I want to choose the end point. So I'm going to shift or hold the shift key down and right click and then choose endpoint. and I want to choose the endpoint of that arc right there, okay? And so now if I select this, you see it's only this and it doesn't get the arc. So I'm going to do the same thing here is I'm going to choose break at point and I want to select it at the endpoint. I'm going to shift right click endpoint and choose that. Okay, so now that's been done. So I need to lay these guys in on the existing ground. Now, obviously, you've got that break line that's already in the surface, that has the elevations. We could have used that as well, but we'll go ahead and use this to elevate these particular ones onto that surface. So how do you take a 2D polyline and put it on that surface? Any clues? 3D polyline.
I don't. I mean, can you convert 2D to 3D?
That's exactly right. That's what I wanted you to think about. So I'm gonna switch back to my civil module and it's on our 3D data menu and I'm going to convert 2D to 3D polyline. These are all my tools. Now I can do it by screen entities and it would read all those little crossings there, but I've already made a surface from all of that data and it's really accurate. So I'm going to choose by surface model. So if I choose that, there's my surface, e.g. break lines and points. I'll say open. Now select the polylines and lines to convert. So I'm going to select those incoming tangents and hit enter. And now, do I want to add vertices at the grade breaks? Yes or no? So it picks up all the little bend points. Otherwise, it just chooses the vertices of the polyline. And, so it could be over and under in between. So I want to make sure I add vertices at the grade breaks. If I were doing this, for instance, like a sewer line pipe, and I want to put it at the surface and then maybe this vertical offset, put it a certain depth, maybe a water line is 4 feet deep, then I would uncheck this so it only takes the endpoints or the vertices of my 2D line and sets those elevations and it lets it ride in between, but keeps it straight. But for this edge, I want it to follow the ground all along. So I'm going to do that. I'm not going to change the layer name. I'm just going to leave it alone. So I'll uncheck that. So I'm just going to add vertices at all the grade breaks and say OK. And when I do that, now this has become, and this has become a 3D or two 3D polylines. I'll look at that in my viewer just to make sure. And you can see there it is. It comes around all the way around there and it comes up here to my edge where I'm going to come off into my parking lot. That's what I'm after. Okay. Now, so what we're going to do, we've set these edges. We're going to set this parking lot at an elevation, and then we're going to float these arcs between the endpoints of the tangents and the endpoints of the parking lot. Okay. So now, what would we want to do with the parking lot? And there's several things we could do. We don't want it to sit on the existing ground, but we want to make it a graded surface. We're going to make that into a pad, so that we're going to grade it at a particular surface. So a couple of things we can do with that as well. We have a tool on the surface menu called Design Pad Template. And what this allows us to do is to select a polyline and say we're going to turn that into a design pad. Now, typically pads are closed, like building pads and things like that, but they don't have to be. They can be open-edged as well. And so it's going to ask us for that, and it's going to ask us for a particular slope that we might want to use, or a particular elevation if we're going to set it as a flat elevation. We could set it at a flat elevation, then we tell it we want to tie into the existing ground, and it computes all of the cut and fill and stuff out here to tie this in. So what we'll do with this now is we'll go ahead and choose this design pad template, and we're going to tell it to set in here. So that's going to be what we'll ultimately do. Now, a couple of other approaches that we can do with this. Right now, this is a 2D polyline, but we could look at this and analyze it and say, well, here's 13, 10, 11, 12, 13, 14, 15. Well, I may say I want this to be at elevation 13, 12 and a half at this corner. That's like halfway between those two contour lines. And then I might want to establish a line that comes down at a certain grade. You know, a certain, maybe I'll put a 2% corner grade. Well, I wouldn't do it this way necessarily. I might do it, you know, down this way. So if I have this corner at 12 and a half, this corner, if I kept that at 12 and a half, it's going to be down, dug into the ground here, which would be fine. We're looking at 15, 14. So you're looking about a 13, 14 about at the entrance here. So that right now on the ground is higher than this point, but we want to drain our parking lot out here. Actually, we would really put an inlet here and drain to our ponds back over here would be what we would, you know, probably should normally do. So maybe, yeah, let's do it that way instead. So if I look at this, I've got a polyline here that starts here and goes all the way around the corner to here. And so I could say set this elevation. Let's do it this way. If we set this elevation, and by the way, now that I've selected that, I'm gonna right click and choose copy. And I'm gonna put a copy down here so we can come back and do that again in a minute. Actually, let me undo that. I want to do this two different ways. And instead of hitting undo a number of times, I'm going to just select those two arcs and the parking lot. I'm going to right click and choose copy. And I'm going to just drag a copy of it down to here. That way, we're going to do this a couple of different ways so you can see the ways we can do it. So one of the ways that we could do it is with this design pad template. The other way is we can set, and we know some elevations that we really want. We want to start here at 13, 14 and a half and let it come down over here to 13, 12 and a half, and then work its way back up here to say 13, 13 and 75 maybe. All right. So one thing we could do is let's go ahead and turn this into a 3D polyline. So we'll go to 3D data, 2D to 3D, and let's do it by start and end elevation. And so when we do that, let's check right here. So this is the start. So this is actually defined in this direction because that's my start point. It wants to know the elevation I want there. Well, I'm looking at these existing ground contours. I'm going to be close to existing ground here. So I want to set that at, there's 10, 11, 12, 13. There's 14. Let's call that 13, 13.75. So now as it goes around, now we'll fix this corner in a minute. We're going to come back around here and I want to set that one at 13, 14.5. So 13, 14.5, hit enter. Okay, now it says select a polyline to assign elevations or enter to end. We're done, so we'll hit enter. Now, we have this, along with these, that we now have as a 3D element that started at that elevation and worked its way all the way around. But so what is the corner elevation back here? And you can look at that a number of ways. You can select it and step through your vertices. There's 13, 13.75. That corner is 13, 13.86. and that's 13, 1408, 13, 14, 24, and then finally 13, 14, 47. So it did the start, it did the end, and it made it a continuous slope all the way around. Okay. But that's not what we want. We want it to start here and go down to a low spot and then maybe start here and go down to that low spot. And we could have done this by breaking this at this corner, doing this one first, then doing that one next. But here's how we can change these resulting elevations. It is now a 3D polyline. So I'm going to edit this 3D polyline. And if you do that, by using the vertices, I'm going to keep that one. This one, I don't know what it's supposed to be, but this one, I do know what that one, I need to make that 1312.5. But I would have to calculate what this is in this corner to give that a nice, smooth transition down. So instead of doing it with the properties, let's use Carlson's tool on the 3D data menu, and this is our polyline elevation editor. So when you select that and then choose your polyline, there's the elevation editor. A couple of things happen. I see over here, I've got these little red markers, and it tells me 0.1 to 0.6, and it gives me the elevations. Now, I don't see the elevations down here because they are not what are called control points. And you see here, and if I do turn on different ones as control points, you would see those light up with the same information. You see how that's coming up, and it's showing you what those are. So these are basically saying, I want to hold those points at a specific elevation. If they're not held, they're not going to be, they won't show up here. And you can look at your settings, for instance, and right here, this is where I said label the control points. But if I said label the non-control points and say, okay, now you'll see all of the labels. The non-control points, though, are blue. So I'd like to actually not show them because they're going to be in there. They're in my list. So how do I set this point down here at a specific elevation and let this one float and let these two up here float? So that is 0.123. And if I sit on 0.3, notice it puts my little grip, it shows me where it is, it centers it on the screen. Now I'm going to make that a control point. So I'm going to click it to lock it. And right now it has an elevation of 1314.081, and I've got an incoming slope and then the outgoing slope. So it's all at 0.1%. So if I take that, lock it, excuse me, and let's change the elevation now. We know we wanted that to be 1312.5. So I'm going to type that in my elevation field and hit enter. And so now you see what it does, and you see a little profile down here that shows you it starts up here at 1375, and then it goes down at a negative 0.378% until it gets to that elevation of 1312.5, and then it starts climbing back up at 0.477% all the way around until you get to the end at that 1314.5. All right, so now I've got these 2 points and that point are set. So that's all I need to do. I'm going to just say apply and close. So now it's going to make that. When I select that and step through my vertices and my properties, I see there's 1375. That one now is the interpolated elevation is 1313.35, 1312.5, 1313.27, and 1314.35, and finally 1314.50. Okay, so it all works down to that point. Now the slope between those 2 points, from the entrance down to this corner is what? Let's check it. We're going to go to our draw command and draw a 3D polyline. We will not prompt for elevation. We're going to let it read what it finds. We'll hit enter or OK. I'm going to snap to that endpoint and then snap to that endpoint. And there's now is my line. And if I want to see what that slope is, I can just use my drawing inspector on and off. I will turn off my curve data, but turn on my polyline data. And if I hover there, that has a slope of just negative 0.5%. Well, that's probably not really enough to drain it. Really, I really should have like a nice 2% cross slope down there. But you get the idea. So you're going to use tools like this to help us. I'll turn off my drawing inspector now. So we're going to use tools like that to help us evaluate what these are going to look like. And if we find out we need to make it a little more drainage, we could either lower this a little further. In fact, why don't we do it this way? And let's do that again. I'm going to go back to draw 3D polyline. Again, I'm going to go from this corner here. Well, let's go from this upper corner now and go down to that corner. Okay. And we'll see what that slope is. We're going to do that same editor. Go back to 3D data polyline elevation editor. And we'll select this one now. So I've got 2 points and I see it's got a negative 0.77% slope. So if we want to change this elevation, so I'm going to make that a little deeper into the ground and maybe cut out some of this stuff to get my drainage into my pond. But I want to put this at a nice 2% downslope. So if I sit here at this point, and you see that slope in is negative 0.77, so I'm going to say -2. And if I do that and hit enter, oops, let's see, -2, enter, why is it not? Maybe I have to uncheck that, -2. Let me cancel that and try to redo it. Yeah, I've got something locked up here. So let me save my drawing first, and now let's go back and do that editor again. So if I select this, there's my 2 points. I want to select this and put that in at a -2%, hit enter. There we go. So that would make that elevation, instead of 1312.5, that would make it 1309.3. Well, that would be down here. So there's 1310.9. So it would be, right in there. That'd probably be okay. All right. Now, otherwise, we could, let's say, let's make that instead of quite that low. Let's select that point and let's make that 1310.5. So that's now raised up a little bit, but my slope is only 1.54. So I could tell it to change this slope. Now I could, change to push this point up here, make it higher instead of, and still achieve that 2% slope. So to do that, to set the slope coming backwards the other direction, I need to change the direction of this line. And that's what my little tool up here does, is to reverse the polyline. So when I reverse it, it puts 0.1 up here now at 1310.5. and it goes to 13, 14 and a half up here. And so now I would sit on point number 2, because that's one I'm going to change. And I'm going to put its incoming slope in at 2% and hit enter. And that would make that elevation 1315.7. So that would put it right in here. It'd be a little higher than that. So maybe that's what we'll want to do. So let's apply that and close that. Okay. So now we have a situation like this, where we've got this one white line. You see, we went a little under down here and we're a little over up here. So we have to adjust this blue line to meet that white line there. Okay. Now, if you remember, we were at 1314.5 earlier, but now this one is at sitting at little grip, it's at 1315.7. So we went from so we basically raised it a foot and a quarter. Okay. So I want to sort of raise this other one about that same level over here. So I'm going to go back now to my polyline elevation editor. I'm going to choose this, and I'm going to change that elevation there. I'm going to add that foot and a quarter. So that's going to be 13, like 1314 exactly. So if I say 1314 and hit enter, is that right? No, it's 1315. Sorry. Is that right? Yeah, 1315. So I've now set that corner. And now to be able to change this corner and this corner, I'm going to come down here to that corner number 2, and I want to have it match the elevation of this white line. So instead of knowing what the numbers are and typing it, I'm just going to choose, I'm going to sit in that point, and I'm going to choose from these elevations. I'm going to say, set the elevation, pick the elevation from the screen, or you can pick it from a surface, different things. So I'm going to say, pick the elevation from the screen. So I do that, and it wants me to then pick the vertex elevation, pick a point, or you can pick text. So I want to make sure I pick the end point of that line. I'm going to shift, right click, end point of this white line. And that now has set the elevation there at 1310.5. Okay. I'm going to do the same thing here for 1314.5. I'm going to set it from the screen, and I will shift right click endpoint, get that one. And so now that's adjusted that to 1315.7 basically. And now I'm going to apply and close. And if you look at these two things in 3D now, you see that we've brought that blue edge to meet all the way around. It starts there, we raised it, it came down to that point. There's a nice 2% down slope. Now it looks like this point might actually be higher than that corner there. We'll take a look at that and see. So I'm just going to go to the polyline elevation editor again, and I'm going to look at those elevations. So I go from 1 at 1315, 1356, 1310 and a half, then 12.5, then 15.3, and then 15.7. Yeah, see that's a little higher than here. And I really might want to have this point be a little above that point. So I might want to say, um, so I want to set this elevation here so that it doesn't drain into this corner. I want this corner to go out and meet the edges out here, okay? So to do that, to set the elevation down here at this point, that's that point right there, number 5, and that's this one marked. I'm going to make that a control point. Okay, but the slope that I use to control that elevation is the incoming slope. That's the slope down here. I don't want that. I want to control it from the start back to this one. So I'm going to reverse my direction. So when I reverse the direction, it's now point number 2. So there's the first point, there's the second point, and it goes down at that negative 1.3%, 1.238. So I'm going to change that instead of that. I'm going to make that a positive 2%. Now it enters. So now, and you can see in the profile, it's going to start at the beginning. It's going to rise up to the high spot. It's going to come down to the low spot down here, which or down here rather. So it goes from this high spot evenly through that point to that low spot, and then it climbs all the way back up. So that now would be what I'm going to use for my edges. I'll apply that and close it. And now when I look at these two features in my 3D, I can see that corner is now no longer above it. I've got this one is actually, see how that, let's give it some exaggeration here. See how this upper corner is still above that corner. So it climbs up and then it goes down. It climbs up and then comes down, down, then up, up. And it's all consistent and it matches this line. So there'll be a nice 2% cross grade on my parking lot. Okay. Now I don't need this surface anymore or this line. This is our little construction line. So I'm going to just take it out. Now I've got these elevations are set. These elevations are set. So how do I then set these elevations around my curb edges or my curb returns? And the answer for that is I'm going to go back to 3D to 2D to 3D, this time by screen entities. I'm not going to do it by a surface. I'm going to choose screen entities. And I'm going to choose to ignore 0, extrapolate the ends. I don't need to. I'm not going to keep the existing polylines. I'm not going to put them on a different layer and use elevation of proximity entities. No, I'm exactly connected. So I'm just going to say, okay. And now select the things to convert. So that's these two arcs. Well, arcs and the little tangent that goes connected. All right. So I've got those selected. I finished my selection. It says now select the things to tie to. So I'm going to select, this guy, and this guy back here. And I'll say enter. And now it tells me it converted two polylines from two intersections. So let's take a look and make sure we did it right. So I'm going to select this, and this, and then this, and this. And let's make sure everything lined up. We'll look at that in 3D. And we look at that, and indeed, we did. We've accomplished what we had intended to do with this. Okay, with me so far? And see how I use this viewer? And let me put that exaggeration back down. So that's now more what it looks like. It's going to climb up and make this little raised pad, but it's got a low corner in it, so it drains. Everything's looking happy. All right. Now, how do we tie this into our existing ground? We know that down here it already meets the existing ground, so I don't have to do anything with this edge, but I do need to tie this because this climbs up out of the ground or goes down into the ground, whatever it does, and it needs to tie to the ground. So does this. And this is where that design pad template comes in. I'll show you how that's going to be helpful for us. So we could do it a number of ways. We could do each one individually and then worry about the overlap, but let's connect this incoming line and this outgoing line to this line so that it makes it into a um, connected curb feature, or this is going to represent my outside back of curb of my parking, and this paving up here is going to be that edge. So that's the part I want to grade into my existing ground. Now there's two ways of doing that as well. The first thing we're going to do is we're going to join these returns into our outline. So let's join nearest. It's on edit. There's the icon. You see the little two arrows. It's also available up here on my polyline toolbar, which is right there. Right there. So join nearest. Now I'm going to give it a minimum gap here, but I have no gap, so it won't apply. And then how do I want to connect it? And if there is a gap, you can have it average those two endpoints together or directly connect them with another little connecting segment, or you can extend them to the intersection. Well, right now, none of these will matter because they are connected. So I'm going to say directly connect endpoints, convert them into polylines. They already are polylines, so that won't matter. I can tell it to only join identical layers and all kinds of filters here. That's fine. Or even only join identical elevations. So if they're not matched, they won't try to join it otherwise. So I'm going to say okay. And now select the lines, arcs, and unclosed polylines you want to join. So I'm going to select that incoming radius, that parking lot outline, and then the outgoing return, and hit enter. And now when I select it, I see I start here and I come all the way around and go up to here. Okay, so I've got my edge. Now, how do you tie that into, I'm going to save my drawing. How do you tie that into the existing ground? And there's two things we can do here. First of all, this is now a 3D polyline. And let's say if I wanted to offset, let's say that's the back of the curb. If I want to offset inside here, 6 inches to make my top of curb and then put a face of curb on it, that sort of stuff. When I'm in 2D, I can use a standard offset and I would offset it 1/2 foot. But because this is a 3D line, I can't do a regular offset on it. If I were to try to do that, edit, offset, standard offset, and if I say, 0.5, 1/2 foot, I select the entity. When I pick that entity, it's going to tell me down here, unable to use the selected entity, please pick again. That's because that's the standard AutoCAD offset. It only works on 2D entities. So Carlson has a 3D offset. And so we can do that and say edit, offset. It's not here where you would think it would be, but it is down here where we have some 3D polyline utilities, and it says offset 3D polyline. And if we do that, we have several different ways to offset that polyline. So we're going to go this interval method where it's going to ask us a horizontal amount and a vertical amount. Okay. And so we're not going to change the layer. We'll just keep it the same. And we will say, we'll make our slopes perpendicular to our polylines. We'll offset by interval. We'll say, okay, and we're going to answer the questions at the command line. First, it's asking for my horizontal offset amount. I'm going to say 0.5, 0.5 feet, that's 6 inches. I hit enter. And now it wants to know a vertical offset amount, or I can change it to P for percent, D for degree, R for ratio. But right now it's just a vertical amount. So I'm going to say 0, hit enter, and I'm going to select my polyline. and then show it the side I want to offset to. So I'll click over here. Now I've got curbs and they come all the way around up to here. And I'll show you what we'll do to fix that here in a minute. So if I look at both of these now in my 3D viewer, they are, sitting there at the same elevation, but just 6 inches away from it. Okay. But I don't really want my curbs to come out here. I want my curbs to stop right there at the edge of my parking lot. Well, you could maybe want to have your curbs out here, but then you'd have to, tie in these edges back here. So let's see. Yeah, we can leave that. I was going to say, what we could do is just, erase these portions of this and just have it stop here. But I think I'll go ahead and leave them out here. We'll go ahead and we'll curb our returns and everything, make it a nice parking lot. All right, now, how do we set the face of curb? Now, here's the problem right here, though, is that this is the top of our curb, and I want that to be down here at the surface and not, well, follow what we're going to do here. We're going to set now the face of this curb. So I've now got the back, the top, and I'm going to now drop it down 6 inches and nearly vertical. So I'm going to kick it out just a little bit. So I'm going to go back to that 3D offset. So 3D, it's on the edit, 3D polyline utilities, offset 3D polyline, again by interval. I'll say, okay. Now this time my horizontal amount, remember, I can't have a vertical face. So I have to have it leaned back just a little bit. And I'm just going to call that 0.05, just half a tenth for my horizontal offset. But my vertical offset, I'm going to go negative 0.5. So I'm going to drop it 6 inches. Now select a polyline to offset. I'm going to take this inside edge and I'm going to come to the inside and I'm going to change the color of this so you can keep track of it separately. So that's now my face of curve, top of curve, back of curve. Now, right now, remember, this back of curb line goes from up here wherever it is, and it ties into the existing ground right here. So these ends, this one is also, at that same elevation, but this one is 6 inches too low. So we need to sort of taper our curb at that, as this comes around, we're going to taper this line here so that it doesn't go from, it doesn't stay at 6 inches there. We're going to come into, say, about midway down the curve, and then we're going to start tapering that into that same elevation. All right, so how would we do that? We basically need to raise up this point right here to match that elevation. And then that matches that elevation. So we're going to do that using that same 3D editor. We're going to say 3D data, polyline elevation editor, and we're going to choose that yellow polyline. Okay, and so that now goes from where it starts all the way around here, it ends at 0.48. So if I'm gonna set 48, that's this one down here. And it now comes into this as a control elevation. I'm going to uncheck that one. And so now the previous control is back here at 29, and I can see where that is back here. So it starts here and then tapers down to match it from this point here. But if I, put that that's like a 3.282%, or that's fine. So I'll uncheck that. but I want to come in here and I don't want to start my taper from up here. I want to start my taper right in here. So I'm going to just select that point there, which is 0.40, and I'm going to make that a control point. Okay. So now it comes around here. It's all set to the right elevation. It comes down here and it's still 6 inches below these two. But from here, I want to go around to the end of it and have it rise to meet that same elevation there. So 0.40 to 48. So I'm going to sit on 48. And instead of having that elevation, I'm going to pick the elevation from the screen and I'm going to say shift right click endpoint of that right there. So 13, 13, 34. Okay, so that now means from 29 to 40, I've got this negative 3.282%. And then from 40 to 48, it goes less steep because it's rising up to meet that same height. Okay. So that's good. I could say apply and close and then repeat the command, or since I know I need to do this one also, let's just stay in the editor and you can do that by this icon right here to select a new polyline. So I'll choose that one and I'll zoom in here, make sure I get this yellow polyline here. And I see I've got this same situation. Now, if these numbers should happen to be, and I think they are, there's 1 to 2. So see, I want to control this, but I need to do it from here this way, not from here that way. So I need to reverse the direction. So I'll choose this reverse the direction. And now it starts over here and comes around to here. So now my endpoints, I go from 26 to 27 to 28. Is that we're in 20? I can't read that. It's no 46 to 47 to 48. Wait a minute. What am I looking at here? Yeah, it goes from 29 to 47. There we go. So 29 is this point here, and it comes into 47 at this slope. Well, I'm going to uncheck that there, and it would now start here and go all the way down to here. Again, it's 6 inches too low. So I want to sit right in here and make that my control point. So I select it, it's highlighted, I click on it, and then I go down to my next one, this end point, and I'm going to set that elevation by the screen. I'm going to zoom in down here, shift right click and choose endpoint, select that. It now matches that. So you see my slope is now changed from a 2% into a 5%. So I've got a 5% slope and then a 2% slope to come in there. I'm now good to go. I can apply and close. So now let's take a look at everything we've got in our 3D and see if we can see that difference here. I'm going to zoom this up, spin it around, and now you can see how it's 6 inches low here and then it tapers up to meet the ground. Same thing on this side. It's 6 inches low in here and it tapers up to meet the ground up here. All right, so that's going to be a nice little well-defined edge for my parking. Now, again, how do we tie it into the existing grade? So we want to take this outermost line, this back of curb, and we want to tie that into the existing ground. Well, we can do that two different ways. The first way we do it is that same command, edit 3D polyline utilities, offset 3D polyline. And this time, instead of using the interval, we're going to target a surface. Okay. And when we target that surface, we're going to say, okay, And it asks us if we want to round the exterior corners, we will. And it wants to know what slope format do we want to use. I'm going to use a ratio of a slope and then select the polyline to offset. So I'm going to zoom in down here and get this outermost. I'll select that polyline, find the surface now that I want to go to. This is my EG break line points and say open. And now it wants to know if it's in fill, what ratio do I want? Well, I'm going to put in just 3-to-1 side slopes. You can type any number you want in there, maybe 4-to-1 or whatever. So 3-to-1. And if it's in cut, I'll also keep it as a 3-to-1. Now, which side do I want to offset? Either this way or that way. So I'm going to go to this outside edge. I'll do that. And there now would be, and I'll hit enter to finish. And if I look at all of these things together now, that would be, if I were to grade that curb line and then tie it into my existing ground, it's going to look like that. And I can verify that by going to my model, adding my surface to look at it. So you see how there's my daylight line as it comes in and hits that existing ground. So right up here, it goes from being in, this is all in fill here. And at this point, it's going to be in cut. So that's why you can't see the parking lot because it's actually underneath back here on this back corner. See how the parking lot comes down? So that's going to be underneath that. Now I can change my surface visibility a little bit. My properties, I'll make it a little less opaque. And now you can see underneath that surface. Let's make it not quite so opaque or so transparent. There's a little bit better. So now you can see where it goes in, but it has to jump up to here to meet that existing ground to actually cut that corner in. Okay. So that's one way of doing that. And then we could do something like this. We would just isolate as layers and we would build a surface just using these points. We wouldn't use, this edge over here, but so we need to put we don't even really need the boundary because it'll jump that gap, but we would build a surface out of this and call it our parking lot surface, and then we could merge it into our existing ground. So that's one way of doing that, okay? And not a bad approach. So I'm going to select that little daylight line that we just created. I'm going to get rid of it, delete it. And so here's the other approach that we can use. I'm going to now restore my layers back, save my drawing. And we're going to use this tool up here called Design Pad Template. It's on the Surface menu. And this Design Pad Template, we're going to use that to set the slopes, and it's going to give us some additional capabilities. And we're going to try that and see how that works with our parking lot. For right now, I want you to go just over here on this side. Let's just draw us another little rectangle. I'm just going to say draw a rectangle, and I'm going to draw like that, just something like that. Okay. I want to show you how Design Pad Template works just as a typical building pad, so you can see how this applies and how we're using a special case of it. But here's how it normally would work. I just drawn a little rectangle up here. Okay. And I'm going to make that into a pad, and I'm going to tie it into this existing ground. So if I go to Surface and choose Design Pad Template, I now have, what do I use for a target? Either screen entities or a set elevation, like maybe if I'm doing a pond bottom, I can set to a specific elevation. But I'm going to go to the surface file. Now it wants to know the slope direction from a closed pad. Now this is a closed pad. My parking lot edges up there are not closed. So if I use a closed pad, am I going to the inside, like maybe to an elevation, or I'm going to go to the outside where I'm going to hit the surface? So I'm going to choose outside. I'll choose ratio as my slope format. I'm not going to have any grade limits. I'm not going to have any of these checked up here. I will round the exterior corners. I'm going to draw the side slope polylines. I'm going to color the polylines. And I'm going to set those side slope lines every 10 feet, 10 degrees around the corners as it rounds the corners out here. And I'm not going to trim any existing contours inside. I've got shrink and swell factors. That goes into applying the earthwork volume calculations that you can do. And it also, I'm going to put it on a particular layer. Let's just, we'll call this one C dash site dash pad. Okay. I'm going to say OK. So now it asks me at the command line to pick the pad polyline. Well, here it is. I'm going to select it. And now to pick the target surface, there's my EG break line points. I hit open. And let's just go with 3-to-1s again. 3-to-1, 3-to-1. And now it wants me to set an elevation for this pad. And it tells me the line above that the range of existing elevations all on the pad go from a low of 1298.31 to 1306.43. So if I want to sort of get it balanced, I'll go to sort of halfway between that. So 1298 to 1306 would be like 1290 or 1302 rather, something like that. So let's say 1302.5. And there it goes. And it says, do you want to adjust the parameters and redesign the pad? You can say yes or no. If you say yes, let's say yes. Let's change their slopes to 4-to-1s instead of 3-to-1. So 4-to-1, 4-to-1. Keep the same elevation. Offset the top of the pad, no. And so it recomputes. Now do I want to adjust? I'll say no. And it, and had I checked on, if I go back to that command, if I had checked on that I wanted to calculate the pad surface, this guy right here, and calculate earthwork volumes, it would do all that stuff as a result of that command. Well, I'm not going to do it. I'm just creating the geometry, and I'm going to use that to then build another little surface out of that and tie it in. Now, in this color scheme, these are those side slope polylines. They're blue, meaning fill, red means cut. And so if I were to look at that in my 3D viewer, I would see it looking like this. And you can see where it's in cut, you can see where it's in fill. Okay, so that all looks pretty good. And this outside edge is that perimeter. And so what I would do is maybe isolate this layer. I would triangulate and contour, and I would use this outside line as my inclusion perimeter polyline, and then build that surface. All right, so I'll restore my layers and then maybe merge that into the existing ground surface. Now here's the advantage to using that design pad template is right underneath that command is edit pad template. So if I choose that, it now asks me to pick the pad. So I'll go over here and pick that polyline. And I get this little box over here on the side. And there's my existing elevation. There's my 4-to-1 side slopes. It says no volume right now because I haven't processed it yet. I'm going to hit process, and it actually calculates the cut and fill to make that pad. Now I gave it about a mid-range elevation, but you can see there's more yards of cut than there is of fill, although it doesn't identify what it is up here. I can look at the report. And I can see, here's my, I've got, 1,000 yards of cut and only 627 yards of fill. Well, what can you do with this now that you're in this editor? Let's say I needed that to be balanced. So I can choose, and you have to hit process first, like we did. Now, if I said balance, it wants to know, all right, here's my target. I want 0 import and 0 export. And I'll say, okay. And you see it reshapes itself and the numbers recompute up here, 809. Oh, by the way, I apologize. I meant to try to remember to turn this thing on so you can see my cursor. There we go. Now, so it has now changed. It kept the side slopes, but it adjusted the top elevation and then recomputed where it intersects the existing ground at 4:1, such that I'm sorry, I did it again. I meant to hit the report button so that we have 809 yards of cut, 809 yards of fill. So that's balanced. Now, let's say we need 2,000 yards to haul out of here. So I'm going to say 2,000 yards as my target for export. So I'm going to use that pad, but I need the 2,000 yards somewhere else on my site. I'll say, okay. And so that's what it has to do. So it lowers it even further and it cuts more. And you can see now my report, I've got 2178 of cut and 178 of fill. And that gives me 2,000 yards that I have to haul away. Okay, so when you say balance, that doesn't necessarily mean 0, 0. That means whatever those target numbers are. And that's what we have done in the book, in the exercise, in this part up here, where we're talking about in that putting it all together exercise, when we're talking about this, uh, yeah, where we do this borrow pit. We gave that a specific volume that we needed, and it adjusted all of that to where it met that volume, um, to then be able to compute. And then you can even, while you're here, you could just say, write the tin file, and it's exactly the same as if you isolated that, you chose that as your inclusion, you grabbed all those things, and it created the, the new tin file and saved it. Again, I'll just look at that in my viewers. So you see I've got a bit more here to make that volume. So all of this stuff using that design pad tool, it combines a bunch of this stuff that you don't have to do independently. Okay. So I'm going to say exit to, oh, let me do that one more time. If I do my pad edit and select my pad, that's not just the only thing you can do is just to do the balance. So I'll process that again. And let's say I want to just move the pad. Let's say instead of there, I wanted it over here. Now, once I've moved it, I hit process and it does that very same thing, but recomputes it for where it is in this new ground. If I move a vertex, let's say instead of being there, I'm going to put that up here in this corner here. I hit process. And there now is what that computation would be. And again, you can see in my report, I've still got, well, no, actually, no, it kept the elevation, kept the slope. So I would have to do the balance again at this point and put in my 2,000 yards. So now, when you do the report, there's your 2,000 yards of export. Okay. So that's why using design pad, and then you can edit your pad. You can do all these different things, move it, rotate, move it, rotate it, and it just recomputes all of that grading all there together. Okay. So I'm going to exit that, and now I'm going to erase everything on that layer. You remember that command? It was edit, erase by layer. Make sure nothing's in my list. I'll select layers from the screen. I'm just going to pick one of those lines. Now, those lines, those red and blue lines, the only thing they're there for is to give you some visual clue as to what the thing looks like. It just helps show you what's there. They're not necessary to compute that surface, but that's what they are. So now we have um, a surface here that we're going to use that same command on. So I'm going to do a design pad template, go back to the surface, design pad template, and again, we'll do a surface file. We'll round the corners, we'll draw the side slopes. Now this pad is not flat, but you'll see what happens. So I'm going to put this one on a different layer here now called C site PKLOT dash grade or GRAD. So that'll be the grading for my parking lot. And I'll say, okay. It says pick a pad polyline. Well, I'm going to take this outside line. That's the same one we did the offset 3D polyline on. I'm now going to target that surface and I'm going to give it these side slopes. Well, let's see if 4:1s will fit. I'll keep 4:1 and pick the side. I'm going to go out to this side here. And now, yeah, it can grade like that. So do I want to adjust and redesign? I'll say no, there it is. And if I isolate that layer and then view in 3D, that is the grading of that parking lot from the back of the curb down to the ground and where it hits, okay? So that's my pad. Now I'm going to restore that layer. But I have more than just that pad. I've also got these two lines. So let's isolate all three of those. I get the curbs as well as that pad. And now there's that. Let's take a look at that one now. And now you can see, you should be able to see as we look in here, you see you've got that curb all the way around the inside of my parking lot. Okay. So, how do we, excuse me, how do we make that into a little surface? Let's say we wanted to put some parking islands and things like that in here, and put our spaces and such in. Then the easiest way to do this now that because the floor of this parking lot, remember, slopes down at a 2%. Well, I'm not going to have to worry about setting this. I'm going to draw my islands in here, but I'm going to draw them in 2D. So I'm not going to worry about setting them on that surface while I'm making them. I'm just going to make them in 2D, but I'm going to build this little surface and I'm going to use that to take my 2D drawn islands and 2D to 3D those onto that surface. So it's going to plop them right down on that surface and I'll build the curbs up from there. So let's do that. We're going to make an 8-foot wide um, a couple of 8-foot wide islands here. Let's see. Let's figure out what we're going to do. So I want to say I'm still on my parking lot curb layer. That's fine. So I'm going to draw a 2D polyline. Draw a 2D polyline. We'll use our current properties. Say OK. And now I want to go, I want to start right in here. Let me see. I'm going to take, first of all, I'm going to get this inside line there from that corner I'm going to come up to this inside corner here, snap to that endpoint. So now there's that line. I'm going to offset that line 24 feet so I keep that drive aisle. Now that's 2D, remember. So I'm going to use a standard offset. So edit, offset, standard offset, 24 feet this time. I'm going to pick that line and I'm going to set it over there. So now there's that one. I no longer need that one at the entrance. I'll get rid of it. So there's a drive aisle. And if I want my parking stall depths to be, what's a standard parking lot, like 9 by 18. So if I want to take an 18-foot from there, I'm going to draw another 2D polyline from that corner to that corner. We'll repeat a recent command, which was offset, change the distance to 18 feet. Select the entity. L means last, so it's the last one drawn, and then show it the side. So now I'll select that most recent polyline there and get rid of it. So now there's going to be my stalls. Here's my drive aisle. So there's a stall. I'm going to offset that one again, 24 feet. So I'll be driving here and here, but parking here. And you might even, actually, we probably should, we could have, parking into these edges here, but you get the idea. You would set up however you're designing your parking lot. And so what I'm going to do is just use these as guidelines. This is 24 feet. If I really wanted to make that 18, that'd be 6 feet. So I'll use a standard offset again, this time of 6 feet. I'll take this and go here. I'm going to erase this one. So this is going to be parking, parking. So I need 24 feet off of this one. So I'll offset that one 24 feet. Don't worry, I promise this will make sense here in a minute. So I'll come in here and I'll drive here and drive here, but I can park up in here. I'll do the same thing over on this side. I need a 9-foot or an 18-foot rather. So I'll draw a 2D poly, snap to that corner, come down to this corner, offset that 18 feet here to here. Now select that and get rid of it. I missed the offset. If I offset 18 feet, there, now. So parking, parking, parking. I would do the same thing for this back edge over here. I come in here and here's my drive aisle. I would do another offset of 24 feet. There's my drive aisle. So I come in, I can go here, go around to here, and then maybe put another one here in the middle. So you would, let's see, I'm going to take my 18 foots. Change their color so you can keep track of the drive versus the parking. So come in here, drive, park. So I'm going to park to the inside of here. So I'm going to offset another 1836, let's say. Well, let's say 18 first. 18, so I'm going to go 18 from here over and from here over. That gives me 2 bays. And from here over. And so I'm going to make this my island right in here. So I'm going to draw a 2D polyline from, so I'm parking, I've got parking, parking, drive, parking, drive, parking. So this is my drive. Let me see. I take a minute, I drive, I park, I park, I park. I drive, I park. No, I drive. I'm getting confused. I come in and I drive here. I park here. I park here. I park here. I drive here. So this can be my,
Yeah, and it looks like that second one you offset 18, you're not gonna have access to it because that's gonna be your island right here, where right there where you go down. That's what you're gonna make your island. You're not those bays there. You're not gonna have access if you have it how you have now.
let me say, I park here and I drive here and I would see if I drive in here. So I park, I park here, I park here, I park here, and I'll park along here. So I want to come in here and drive.
I was gonna say that first blue line from the top, that should be a drive aisle between there and the purple. No,
Well, hang on a second. I need another aisle back here around the back edge. Now I'm going to offset that 18. Okay, park all along the periphery. Change that now to, so park all around the periphery. And I come in and I can, now obviously I'm not going to park all the way up here. I've got to get in. So I'm going to come in and I'm going to make this my drive aisle. And this can be a parking spot. Or if I drive and park, see, I don't have the right dimensions on here to start with. But I'll drive here, park to this side. I can park two bays to this side and that I could actually get two bays in there. So we got two bays. Let me, let's make a 4 foot. I got two parking, but I want to put an island in here. Let me push that out 4 feet. No, let me make it 8 feet. I'll park here. We'll have an 8 foot bay. Let me get rid of that one and let's offset. This is the edge of my bay, so I'm going to offset that one 18 feet. So parking, parking, island. All right, I come in here, I drive around, I can park here, I can park here. There's going to be an island in here. I can park here, so I have to drive in here. So these are two parking bays with an island. And if I want another, let's see if I've got room for another one here. So another island, and then if I offset that 18, how much distance do I have in here from my drive aisle? It's 31 feet. So that would give me a larger aisle, a drive aisle over here. So we'll assume it's in good shape. So I now need to offset this one as a 24-footer. This way, we'll make this one this way. All right, so now I'm going to use these to trim. We'll get rid of these two. So I'm going to come in, I'm going to drive through here. So let's select these, trim this. So I'm going to come in and drive. I can park over here. And I can park back here, but I'm going to drive around the corner. And I've got 2 bays of parking here with an island. And if I drive here and park, that's actually more than it needs to be. So if I offset this 18 feet, set my color. So now, no crap. Let's offset that 20. It's my drive aisle. Then what is this distance? $25 feet. So we really, get rid of that. So parking. I've got the drive to park. Fix this right. All right, so drive to park. So if I'm going to offset 18 from here to here, so drive. Park, drive, park, drive, park, and that leaves this for basically a little landscaped area, whatever else. So obviously, my overall lot dimensions are not ideal here. But let's say if I had or maybe even I had a 2-way drive aisle in here, for instance. Let's see. If I offset park, So there, another bay, or an island. There, that one, that one. Can't. Well, let's not belabor this thing. We're just gonna, we'll put in some islands here and show you how we do this to set this thing up. So I'm going to be driving in here. I'll park in here. Um, park along here, park along here, park along here. This is driving. Park here. So actually what I want to do is, it's an 8-foot island. Make it 18 feet here to here. So parking and driving here. So I'm going to get rid of this guy for a minute. And I'm going to take all of this stuff, and I'm basically just going to move it to where the middle of this is like sort of in the middle of my area here. So I'm going to come out. I have these extra wide drive. Let's see, I've got drive here. It's still not. So what is this? This is 44 feet. So if I draw from this corner all the way up to okay, so now see, I'll do that. I want this to be perpendicular to the yellow line. The yellow line. Hold on. Draw my 2D. So I'll set that one just 2 feet. Now I'll be able to find that geometry. And then get rid of this. And then I'll use that to extend this. All right, so if I move all of this stuff from that midpoint to the midpoint of this line there. Now I'm centered. Okay, so now I've got drive, park, drive, park, drive, park, park, and then I park in this direction here. So I've just got extra wide drive aisles in here, no problem. So I'm going to put my islands in here. So I'm going to make these islands 8 feet. So I'm going to take this one and do another 8 foot offset here to here, here to here. I've got the middle. So I'm going to come around here and go around here and around here and just make that like that. And you can put, little interrupter islands all along here if you wish, but just to illustrate the point. So now I've got these that are going to trim that. These are going to trim these. These are going to trim these up. Trim these. All right, so that'll be where my islands are going to go. I'm going to put some little uh, roundels in here. So I'm going to draw another 2D polyline from this midpoint to this midpoint. Midpoint to midpoint. Midpoint to midpoint. Midpoint to midpoint. Now, select all these little edges, trim. And let's put some radius values on there. Let's see what we'll do. Actually, we do a 2-tangent radius. Let's use a 2-foot radius. We'll take this one and this one. And now a 5-foot radius and do this one and this one if it will. That's what I'm afraid of. Well, let's do first of all an 8-foot radius, and we'll get this one, this one. Let's make that a 15-foot radius from here and here. Same thing here and here. A 15 here and here. Here, here, and here. All right, now I want to put in a nicer curve here. If I put in a 25-foot radius. Let's see if it'll let me do from here to here. Ooh, no. Need a compound in there. See if a 5-foot will go from here to here. Well, here's what I need to do. Let's get rid of this. Then I want to radius that into this. See if I can go from a 4-foot into that. That's a little. That's well. Come on here. 2 feet. Finally. All right, now let's join all those up. Verify, there it is. So now there is an island in my parking lot. I now don't need these anymore. So if that, I want to take that line, that edge that I've drawn in 2D, and I want to put it on this parking lot surface. So the first thing I need to do is to build that parking lot surface. Okay, so I've got everything isolated here. I'm not going to use these two edges out here. And I'm not going to bother drawing a shrink wrap across here because it's going to jump that gap anyway. I think, well, maybe not. Let me see. Yeah, no, that should be fine. It should be fine for what I need. Nope, I do need to shrink wrap it because otherwise it'll go in here. So I'm going to um, shrink wrap my entities across gaps, say okay, and I'm now going to choose that. Okay. Let me undo that and do it again and change the reduction from low to none. And now grab all of that. No, put it back to low and then edit our. So I follow around here, okay, except for I need to add a vertex there and add a vertex there, one there. Oops, put that there. Looks sufficient there. Now here I'm going to add a vertex up here. No, you know what? I'm not going to do this way at all. Much simpler way of doing it. Let's just draw a 2D polyline. Let's draw a 2D polyline. And we're going to put it on our layer of site, let's see, topo, what was our boundary? Topo, B surf boundary, that's right. Except we'll call it C. And I'm going to start right here. And then I'm going to follow this yellow line. No, not the yellow, the blue. One more time here. I'm going to start from here. And then I'm going to go across to here. Then I'm going to follow this edge here. The first follow point will be there. No interpolations. And I'm going to follow it all the way around to the end, which is over here. Well, let's see. I did the wrong one again. Get there here, 2D polyline. Start here at this yellow line. I'm going to go to this yellow line. And then I'm going to follow not the blue line, but the green line. No interpolation. The first point will be there. Will be there. Follow this from here. It goes all the way around. It comes out to here. Yes, that's correct. And then endpoint, endpoint, and close. All right, so now I have C surf boundary. C surf boundary will be red, and it will be heavy so we can see it. That's now going to be my inclusion when I make my surface. So I'm going to triangulate and contour. I'm going to write the file. Welcome back, William. So I'm going to write this file now as my PK lot. Just call it -1. Use the inclusion. I'm not going to draw any contours. I'm going to say, okay, there's my inclusion areas. no exclusion areas, and then everything to model. It's built my surface. I'll verify that with my viewer. And now you can see it comes in there. It's tied down to existing grade. The curb elevates. It comes around and it goes through my parking lot all the way around to the edges. And so I've got this nice little surface that I built. I've got a little bit of tweak in there that I might need to try to resolve. Let's see. Well, for the point of illustration, I'm not going to chase down that little nag point. So, but what we've got is this parking lot now is sloped. It has a sloped surface down to this corner. Remember, we did that inside edge, but this is now drawn and it's not, um, it's just in 2D. So I want to set that on my parking lot surface. And William, what we did when you stepped away is we just shrunk wrap all of this parking lot data and built the surface out of it. So that's really essentially what we did there. And so now if I want to drape this on this ground, I would go to 3D data, 2D to 3D by surface model. This time I'm going to use the parking lot as my target. And I'm going to drape this on it. And yeah, that's fine. We'll say okay. All right, so now I should have all of this stuff is now elevated. And this is now sitting down on the pavement of my parking lot. And it has a slope to it. See, if I look at my drawing inspector and I hover over here, I see it's got a 1.29% slope and negative 1.29. On this side, it's 1.52, etc. All right, turn off my drawing inspector. Now, if that's on the ground, let's build the curb. So remember, I'm going to step up and put the top of the curb. This is my face. So I'm going to build the top and then I'm going to build the back. So this will be a curved island. So I'm going to use that 3D offset again, edit 3D polyline utilities, offset 3D polyline. I'm going to go back to my interval method and I'm going to say, okay. My horizontal amount, remember I need just a little bit. So 0.05, because I have to keep a non-vertical face. And the vertical offset amount is 1/2 foot up. So I'll take that line and I'll bring it 1/2 foot up. Now I'm going to do the same color scheme. I'll change this face of curb to be yellow so you can keep track of that. So now this one's raised up 1/2 foot. Now I'm going to repeat that 3D offset, and this time again by interval, my horizontal amount is going to be my 1/2 foot, and my vertical amount is going to be 0. So that's going to be there to there. And so now when I look at that structure in 3D, you'll see how it's built, from the face of the curb, which was targeted to that surface, it raised up the top of the curb and offset the back of the curb all the way around my figure. Okay, you can see it has done so correctly. All right. Now, I could turn that into a surface and then merge it into my parking lot surface, and that would be fine, except that would make my island across here flat. So I'm going to do another little trick here is I'm going to, let's see, what do I want to do? I want to build another little temporary surface here. So I'm going to go back to surface and triangulate and contour, change the file name now to just island. Say, okay, we're going to pick this outermost as my inclusion, no exclusions. And then I'm just going to grab this data right here. That's now been built. I'll verify that. Excuse me. So there's now that, and you can see it's there. And yeah, it's got a couple of issues here. Let me see. Let's go back and rebuild that. So it should go flat across there. It's jumping the shark somehow. Another, let's see, are these closed? Yeah. All right, I'm going to rebuild this triangulation surface, but I'm going to densify these break lines. I'm going to put that on, say, every 5 feet, so I get a little smoother triangles. All right, I'll grab my inclusion, no exclusions, and then grab my data. Now let's verify that with my viewer island. Yeah, that should be, it should work. Sure what's going on up in here. This doesn't look right. It might just be the shading. I think that's all it is. It's just the shading, the shadows. Okay, so I've got an island there. Now it's flat. So if you want to crown your landscaping in here, we're going to draw another 2D polyline. And I'm just eyeballing this at this point. And I'll do the same thing. So just sort of get in the middle, go to the middle, then middle, middle. I'll extend those to meet there. Now I'm going to drape those on that flat island top, but I'm going to raise them up 2/10 of a foot. So I'm going to go to 3D data, 2D to 3D, by surface model. There's my island. I'm going to select these 3 polylines that I drew. And I'm going to apply a vertical offset of 0.2. Say okay, and now they're done. And if I look at that in 3D, you can see those red lines are sitting a little bit above the edges of that island. Okay, so I'm going to go back and one more time triangulate and contour. I'll keep the island name write it. I'll select my inclusion, no exclusions. And now I'm going to have those new lines added into it. It's now built. I'll select my surface. And you can see how it's crowned that see how it's crowned the surface in there so it sheds out to the edges. And I got a nice little, 2/10 of a foot crown into my landscape island. All right, so now I've got an island, I've got a parking lot. How do I put the island into the parking lot? And that goes into our surface menu, and we're going to use triangulation file utilities. This is how we merge different surfaces together. So I've got this triangulation, I've got this parking lot, I've got the island. I want to put them together now. So I'm going to load my 10 file. I'm going to load the base, which is my parking lot. Choose open for that. And you can see that's there. I'm going to go to the button at the bottom that says next, and I'm going to merge a 10. So I'm going to choose this button here to merge, and you can see all these other functions that you can do. I'm going to merge a 10, and the second 10 is going to be inside the current 10's the outside boundary. And you got to transition or just compare and repair the gap, adjust elevation, etc. But this transition will be fine. I'll say okay. I'll choose the island. I'll say open. And now that's what will be the resulting parking lot with the island sitting on it on a sloped surface. So I just come down at the bottom and I'm going to check that I include all of these inside borders and outsides. I'll say save as, and I'm going to call this one parking lot. Instead of one, I'll call it final. It's now saved. I can exit that, verify my parking lot final as a surface. And you can see there it is. Oh, I know why that's showing up like that. I'm so sorry. I had set the opacity here. Let me put it back up to, there we go. That looks a little nicer. So now you can see all the way around, you've got your nice curbs are elevated. Comes in here, you've got your island and it's crowned. All right, so that's all, and it's all tied down now to the existing ground. And so then you can do one final merge under surface triangulation file utilities, and let's load in for the base our existing break lines of points. Oops. E.g. break line points. Did we? Somehow got rid of the boundary around. Well, anyway, don't the shrink wrap boundary. So we'll go next, and now we're going to merge into it this parking lot final. And let's turn that on. And you can see how that would be all tied together. I'm going to do a save as now and call this one final site. Again, verify that. And boy, I don't know how I wound up losing that boundary. But anyway, you can see how this surface ties in all the way around. And we'll use that to drape this along the surface. And it slopes down to this corner. We could just put an inlet and a pipe, daylight it into our pond, and bada bing, bada boom, we're done. And to illustrate how this is going to, what happens when it rains, I'm going to switch over to the hydro module just quickly and choose my runoff tracking. And I'm going to use that final site. And I'm going to use pick individually and say, okay. So now it's going to read the surface. So as it's reading.
Hey Ken, I have a question.
Yes, sir.
Um, just thinking big picture. So like you have an island now in the middle. So some of that water is not going to be able to get across this parking
Yeah,
lot. Is that true? Are you going to have to put a curb inlet in like that bottom or the bottom
exactly.
right corner?
Exactly right. Like probably right there. Okay.
Yeah.
So here's what we're going to find out. I'm doing the watershed, the runoff tracking. So if I click a point now, it's going to hit that curb and go down the edge here. If I hit a point up here, it's going to run down to the inside and then it's going to stop right there. So that's where I'm going to need an inlet. If I do a point over here, well, that'll get around to there. If I do a point over there, and you see everywhere I do these, it's all sloping down to there, except my island's going to interrupt. Now it's going to hit, for whatever reason, it hit a low spot here and then jumped out to here. This goes down and wraps. Yeah, I might want to take a look at why that was low and why this point is lower than that point there. It's something about the cross slope that we did. You know, when we raised this corner up and we did some things there. So this is what I would do is sort of look at that as to find out where those low spots are going to be. So I've got, well, just some things that's kicking it back out. So there's something going on with that that makes this point lower than that point. Yeah, I might want to reconsider this, or I'll finish that. I'm going to erase by layer. Get my runoff tracking layer off. All right, so I've got a low spot in here, but so I could do something like this. If I did a 3D polyline, and I'm going to use a surface model to read my elevations, I'm going to say, okay, I'm going to go onto the island, no, the parking lot final. If I want to put a little swale right here to right here, and to right here. Let me think about this. Now I've laid that on the surface. I want to drop that down a little bit. So I'm going to go to my 3D, go back to civil, 3D data, change elevations, the very first one there. I'm going to use a differential. I'm going to say, okay, and I'm going to drop it negative 0.2 feet. That line right there. Ignore zeros. Yes, it's fine. It's now done. I can verify on my viewer to make sure nothing's goofy, like I did type 2 feet. Yeah, that looks good. And now I could go back to that same, rebuild the parking lot and then redo the merge and all of that and add this into the parking lot. That would be what I would typically do. But we could also do this as a direct edit. I'll go to surface, triangulation surface manager. And I'm going to put in now, island is my current, and I'm going to edit it So I'll just choose the edit button. And now what I want to do is to add a break line. And there it is, add break line. And I'm going to choose that point. Pick point is outside the 10. Oh, sorry. It's not the island, it's the park lot final. So I need to add that park lot final. Make that my current one. There we go. Now, if I edit that, so you see there's that low, those low triangles. So I'm going to add a break line. Pick a point or a point number. So I'm going to grab that point. Now the second break line point will be that point. New edge crosses existing. Yeah. And now I'm going to go from that point to that point. Pick near, and that will be fine. And okay. And now done. So now let's look at our watershed, our runoff tracking. We'll use the parking lot final so it doesn't have to read everything. Pick individually, we'll go okay. And if I pick these points, so in here, see, I still am going to have to catch something there. Although it hits here, yeah, it hits there and dies, it doesn't,
Hey, could we have also raised that bottom right corner parking lot and just raised it up a
oh
few
yeah,
tenths?
yeah. We could have done any number of ways to modify that.
Okay.
So let me verify that parking lot final. See if we've got, yeah, see, we got, there's something amiss. Yeah, see, there's something really bad going on with that. What happened? That's not even where our, you know, this is, this is the brake line that I added was out here and it screwed something up with that. So let's, instead of doing it that way, let's go back to this. Let's rebuild our parking lot final. So let's just go to triangulate contour, make sure our, we'll select the file as parking lot final. We'll say, okay. We select our inclusion, no exclusions. And then let's select this. Build the surface and verify it now. Hard to see that little swale that we put in there. Let's see if we see that. Yeah, see, there's the swale line. So it's in there. Now let's try the runoff tracking again. Parking lot final. So that'll actually hit there and it shows that it's jumping the curb and going on out. All right, let's do this. Let's repeat that runoff. And this time I know what's going on here is I've got a 4-inch rainfall. Let's make that a 1-inch rainfall. And now it should, it still says it's jumping the curb. And see, that's going and crossing and it shouldn't. It should be pulling that down. All right. Let's get rid of that. Let's reset this guy. So let's triangulate and contour and let's build, let's work on not the parking lot final, but the parking lot one. May have been messed up. Let's select our inclusion, our no exclusion, and now get everything except for that guy. Oops. So deselect that. That's parking lot one. Now let's go back to civil. 2D to 3D by surface model. So parking lot one is my target surface. There is the line to use. Use the as vertical offset, no. Apply a vertical offset, I raised it. Let's make it negative 0.2%. Sorry, that's one thing I would have done. All right, so now I've put it in the right spot. We'll triangulate contour and this time make a parking lot final. Choose our inclusion, no exclusions, and now grab all our data. Now let's verify it. So there now the triangle's formed correctly, in my opinion, and then you should be able to see a little bit of that swale. It's really not very much, just 2/10 down. Let's go back to hydro, to our runoff tracking. Parking lot final, 1-inch rainfall. So it still goes down to this corner. It still comes back out to here. That's still jumping. Hmm. Something about we did something with this island incorrectly. Like this point should not be higher than this point. All right, so let's build the actual pavement part of this parking lot. So triangulate and contour. This is going to be our parking lot one. Yes, replace it. Use my inclusion, no exclusions. Whoops. Did something wrong. Yes, and select the inclusion, no exclusions. And now what we want to triangulate is this, but we're going to remove all of this stuff in here. Let's take a look at that. It's parking lot one. Now there is a standard parking lot edge to edge. Now here's something we might want to do. I'm going to draw a 2D polyline here. I'll put that on 3D break line. I'm going to go from, say, here, nearest. I'm going to go from here to here. Parallel. All right, so that is there. Now I'm going to use that. It's on 3D break line. Let's make my 3D break lines magenta so you can tell them. All right, so I'm going to take that and I'm going to just copy it down every 10 feet. And go from there to there's about 10 feet. Copy that from and 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 now copy these from here, 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 here. Get rid of these three. And let's draw a 3D break line. Three D break line. Don't want to use the surface model. Okay. So I'm going to go from there to here. So it should all match. All right, so these are all 2D. So I'm going to choose, go back to civil, 3D data, 2D to 3D by screen entities. And I'm going to choose by fence those elements. And I'm going to have it read parking lot edge. Now let's see what this looks like. 3D. So now I've got the actual, I've got some density that I can get across there. All right, so now if I go to surface and triangulate and contour, I'm going to make my parking lot 1, that's the bare pavement. Make sure densify, my brake lines is on, I'll say okay. hit overwrite. I'll get my inclusion, no exclusions. I'm going to grab everything. Make sure I get those out there. Now I'm going to remove those and that. Boy, what do I got? Ah, ah. Must not have crossed or must not have gone. Let's see, there's something. Huh. Those must have. Ah, I know why. All right. Let's go back to my 3D data, 2D to 3D by screen entities. Say yes. Do a fence selection so I can just drag a line. Now, instead of just using that, I need to also include that line. So now let's take a look at it. We get too far ahead of ourselves. There we go. Now, triangulate contour, parking lot one. Okay, yep. And choose their inclusion, no exclusions. Grab everything. R to remove. I'm going to remove the island and the swale. Okay, up now. And this park lot one. And excuse me, you can see now I've got a much regular spaced triangulation, so that looks good. And if I now drape this onto that surface, so 2D to 3D by surface model, choosing park lot one, select this line. No, I'm not going to use it for offset. I'm going to go 2/10 of a foot deep. It's now elevated. And let's go back to triangulate contour. Same file. Choose my inclusion. No exclusion. Select everything here. Remove the island. And now, even though these cross, they should be at the same elevations. So still going to get some crossing break lines. Oh, it's 2 feet. Yeah, never mind. Got to repeat the triangulation without that line because it was 2/10 deep. That's right. So there's my inclusion. No exclusions. Remove my island. And now I'm back to my surface is flat. Now, this has already been draped on that surface. So how do I add that into this surface without generating those? I'm not going to rebuild it again. I just need to add this into my surface. And I'm going to use that as, because this is sitting 2/10 down. So I need to push it out until it intersects this surface. So that's a design pad or a 3D offset. So if I just do an edit 3D, offset 3D polyline to a surface, I'll go okay. around the exterior corners, and it's fine. We'll go by ratio. Pick a polyline to offset. So I'm going to offset this polyline, targeting parking lot 1. And let's do like a 6:1, make it nice and flat. 6:1. Which side to offset? That side there. I'm going to do the same thing again. I'm going to go from here, 6:1, 6:1, and choose that side to offset. All right, so now if I isolate just these 3 figures, and if I shrink wrap that, better than that, I'm going to just do a join nearest. I'll pick my gap to be bigger than that spot, and I'm going to directly connect endpoints, and I'm going to connect this guy to this guy, and I'm going to break this out a little bit from here to here. Same thing from here to here. So now when I look at that 3D view, I've got a little bit of a sort of ditch channel. I can make that into a surface. Wow, that's not even, instead of a 6:1, let's try a percent. Let's go back to edit, 3D, offset 3D. And let's see, that'll be fine. Let's choose P for percent. Let's choose this, choose that, and let's go 2%. All right, so that looks a little better. And if we look at that in relation, that's why it came out to that edge there, funny. Here, and there's something weird happening in there. Why does that jump the curve? There's something really strange with that. All right, let's go back to this. Oop, I got a straight point down here. All right, let's get rid of this for now. Let's see what our um, see what our rain does now without the island. If I choose hydro, runoff tracking, we'll use the parking lot 1. All right, that's what I would expect, something like that. So it all runs to these side curves and down. All right, so that's good for my parking lot. So I'm going to clear those. Now let's drape the parking lot on the, or the island on that surface. So I'm going to go to 2D, back to civil, 3D data, 2D to 3D by surface model. Parking lot one's my target. That that is the line that's along the pavement. Actually, let's put everything along the pavement. No, don't use them as offsets and don't apply and say, okay. All right, so now everything is squashed down to the pavement. So what I need to do is raise these things up vertically. So I'm going to go to 3D data and change elevation by differential. And I'm going to make this one 6 inches taller, so it's 0.5. So that one and that one. Repeat the command by differential. And let's make this one 0.7. All right, so now that's done. Let's verify it before we get ourselves. Hang on a second. Let's get the right set of data here. What happened to those red lines? All right, looks like my island's okay. Let's set this back. I'm going to say 3D to 2D and put it down at 0. And I'm going to just put these at 0. All right, I'll build the island now. Triangulate and contour. Select, let's choose the island. Let's get the inclusion. No exclusions. Grab all that data. Now the island's built. Let's go to our triangulation file utilities now. And let's load a 10 file, which is the parking lot one. We'll go next. Let's merge a 10 file. See, second thing that Carlson said, adjusted elevation. Boundaries used to add intersection points from both 10s. Elevation of the second 10 is held at the boundary. Offset zone happens. Boundaries missing outline, second 10 is used. Cookie cutter style, second is taken as inside affected. Okay, that's fine. Try that option and choose our island. All right, that looks better now. So if I save that as parking lot final, let's exit that and then view it to make sure. All right, that looks good. We could then add these crown lines. You know how to do that. We would drape them on the island and include that in the island. Probably what let's go ahead and do that 3D, 2D to 3D by surface model, the island, which was the flat top. We're going to select these lines, apply a vertical offset of positive 0.2. It's now done. We will rebuild the island. There's island. Inclusion, no exclusions. And now all of that. What the heck is it doing here? Inclusion, no exclusions, everything, and remove these ground lines. All right, there's the flat. 3D to 2D down to 0. Now 3D to 2D to 3D by surface model to island. We're going to take these lines apply vertical offsets and say okay. There we go. Now one more time to build island. Take your inclusions. No exclusions. This should now fit. Still gives me a freaking T intersection. It's right there. Let me see what it looks like. I think we can live with it. Yeah, so that fits there, fits there. Do have some flats though. Why does this build out here? See, that shouldn't be building out there. Is this not a closed polyline? Yes, it's closed. Island, use inclusion, nor densify. Okay. And this is their inclusion. No exclusions. This should be the surface. If I view that surface, that's better. Okay, once more into the breach. Triangulation file utilities, load up the base, which was my parking lot 1. Or parking lot 1, yeah. Go next. We're going to merge. We'll use the overlap option, choose our island. Let's color that in and view it around here. See, it looks good. We'll now save as. There's our parking final. We'll exit. We'll view that. Parking lot final. Everything looks pretty good. Now, let's go to hydro and track the runoff. So these come down here and it's actually showing it jumping the curb and spilling out. I would still probably want to put an inlet down there. But you can see now everything, hits the curb and walks around it. Um, Down to the edge. It's still right in here though. There's a little bit of a jump. Um, I guess there's just enough water to jump the curb. Let's change that down to 0.2. See if that still jumps the curb. Oh yeah, it jumps all the way across there. Well, anyway, that's the process. And you notice how I kept jumping back and forth into those 3D viewers to check to make sure everything looked right and I could find some problems and come back out and fix them. And so, but again, a lot of ways that we do this is we just build these up in little individual pieces, and use that triangulation file utilities to merge our our surface designs into a composite whole. So maybe I'm designing a pond, I'll do the pond and then I'll add that pond into, all my other data sets. So here's now this, I'm going to freeze off uh, the break line data and the outline there. And now to show you how this will be a grading plan is you could, now let's go to surface and sorry, go back to civil first. Go to surface and let's contour from a tin file. And that one we're going to contour is the parking lot final. And I'm going to draw the contours. I'll put this on. I'm just going to change these layered names to C instead of V. No need to bother with that. With that, erases off. No need to worry with that. We'll say okay. And there now is your grading plan. So you've got, these 13, 15, there's something. See, there's the 13, 15. There's 13, 15. It comes up here and crosses and jumps. So it ties across here. And then it comes up here, crosses the curb, walks itself around, ties back down to there. Here, now I've got a little bit of goofy in here because I should have drawn this outside line from this edge to edge and draped that on the existing ground. Because right now you can see how it's missing that target out there. But, so we would resolve that. But now there's your contour comes here, walks down and it finds that's elevation 1316. There's your 1316 line. So that would basically just tie to there. 1315 should really come down here and see all of these are part of that existing surface. So we really should have, cut this hole out of the existing surface and added this in. In fact, let's do this. If I erase by layer, clear, select from the screen. And I'm going to draw my surface boundary of my parking lot final. So I'll use that to limit my contouring. And I'm going to go next to my triangulation file utilities. I'm going to load up my EG break line and points. I'm going to then merge. Let's see, transition, combine, repair the gap. My parking lot final. Let's take a look at how that looks down in there. I think it's decent enough. Yep. And I will save that as, and we're going to call that our final site. Cancel that and exit. And now let's go back to surface. All right, and I've got, first of all, let's take a look at that final site. So there's now that final site, and you see where it really ties in nicely on that edge. It should fix it all the way around. So if I want to contour that surface, I'll go to surface contour from a tin file. And I'm going to use this final site, but I'm not going to draw the contours out in here. So I'm going to tell it to use the inclusion exclusion areas. Let me check my label sizes. All that's good. Say okay. And now I'm going to use this boundary as my inclusion, no exclusions. And there you see how it ties. Now I can freeze that. Well, actually that line there I should have made a 3D line there and tied that back into the road. That's the problem. So I still get this little kind of damaged looking thing in here that I could fix up. But now there's your grading plan on that site. There's your islands. You see there's your contour, comes up, climbs the curb, crosses, comes back out, and goes back out. So that's, and right in there, see that contour, there's your catch point, that's your low spot. And that's why that has an elevation of 1312. And this one over here is also 1312. So that's where it jumped across there and went over to that 1312 side. Okay, but there's your parking lot, there's your graded parking lot. Here's our surface. Once we get to that, we'll add the final site. And that then is what, we would use to calculate our volumes, for instance. Okay. Calculate your volumes from, again, the surface menu. Volumes by triangulation. Let's use two triangulation surfaces. We'll choose up here, it's asking for the existing. The existing is that EG break line points. The final is our either final site, or in this case, parking lot final would be sufficient. Say okay, no inclusions or exclusions. And we'll just get the report. And here is your 2,400 yards or tons, 1,500 yards of cut, 1,350 yards of fill. So it's pretty good results. Here we see if I wanted to reach balance, I could take that whole site and raise it up 1/10 of a foot. And for every 1/10 of a foot, I get 175 yards. So that's not worth fooling with. But you can see that was pretty well and evenly balanced to design this parking lot. I would still take this and make a 3D line out here, because right now it just went 2D. So it went from that elevation straight to that elevation. And I would normally put that in. I wonder if I can do that with my manager, if I look at my final site and edit it and add a break line. It's in the middle of calculating something here. All right, so now I'm going to add a break line. Pick a point or point number with the first break line. So I'm going to come over here and grab the end of that point right there. So I'm going to go from there all the way up to here. And so when it does that, it's going to recalculate and redraw. So that contour line should come back and work. All right, so now we're going to come out and we come in here and we meet that a little bit better. So this grading, you see, I'm going to have to see that green line is my existing contour. So this would be the adjusted contour there. Is it's just going to pull it up a little bit here. So, and the same thing here with this red one from that green one. So that's how that ties back in. So I had a little bit of an influence going on there. Then I'll say, okay, that's fine. Be done with that. Uh, cancel that. Save the surface. And it's got to go now and calculate and take them all out. All right, so that would be that. I'll be done with that. I'm going to now erase my layer to get rid of those that are drawn out there. And to finally put it to rest, I'm going to draw my surface boundary again of parking lot final, and I'm going to edit this polyline. I'm going to add a vertex, and I'm just going to come down here and add these crown points. Okay, now I'm going to do that for a specific reason. When I redraw the contours now, surface contour from a tin file, and I'm going to use the final site, which is everything, but I am going to use these inclusion exclusion areas. So I'm going to use this line now that I pushed out to be my inclusion, no exclusions. Now I'll freeze that boundary line layer. So now you can see the grading actually does tie into those so it ties right down to that contour line, that ties right down there. So just a little bit of an adjustment in here, which I should have expected because I graded across this entrance. And so I had to push this out and catch that little bit. Okay. So that is basically that process. What is this blue? That blue line is actually part of it's an outline of the existing pavement. Yeah. So it normally came in here and went around and came out, went that way. So there you've You know, that's about as advanced a grading operation as you will run into. And just build these intermediate little surfaces. If I had this as a flat pad and I wanted to put a ditch in it to drain, I would draw a ditch in, drop it down, do design pad to use to catch to my flat top, and then incorporate that into my pad. And then all of a sudden my pad now has a nice consistent slope, but I've dropped a ditch into it, maybe at a differing slope, and you would see all the contours would reflect that. So that's the difference in doing edge design versus trying to draw your contours and trying to, you know, trying to mold the surface wholesale in one step. So you're going to design these edges, put them where they need to go in space, either drape them on a surface, set them at an elevation, set them at a particular set of elevations that have slopes that go down the edges, like we did the edges of this. We created these little returns to start at this corner at that elevation, go all the way around and read that corner and just make a consistent change. Same thing here. And then we did for the face of curb, remember when we did the polyline editor, we used it to come down here at 6 inches deep, and we got to a certain point, and then we let it float back up to tie back into the existing ground. Okay, same thing on this other end. So all of those different techniques are what we do to do our drainage design. Okay, so questions on advanced grading?
Yeah, I got one question. So like, so your typical building is going to have like an offset around the building. Could you draw that as like an offset line and then like drop it like, I don't know, a few tenths and then start your grading from there?
Yeah, let's
You have like a 5 foot offset around I don't know, like a retail building or like a house or something like that.
let's take this building right up here. Okay. There's a command on 3D data called draw building envelope polyline. Put it on a building pad. Let's put it as I say a 5 foot offset. I always say, okay, we'll grab our building. And there now it is pushed it out to this 5 feet away from that building. Now you would have like a finished floor or something here.
Right.
Then you just change that, you know, set that elevation to whatever it needs to be. Put a 5% parge grade on it. Could maybe be the similar type of thing to do. That's one way of doing it. With the building pad, that just took the overall extensions. You could also though do, let's elevate this. Let's give that an elevation of looks like 1298, let's call it. Okay. So you could do edit 3D offset because it has, well, you don't even need to do a 3D offset now because it is 2D. It's all in one elevation. So I could just do a standard offset. So standard offset, let's make it 5 feet. We'll take our building, we'll go out here to the sides. There's now 5 feet.
You could sound at a different elevation if you wanted,
Yeah,
like
so
maybe a
that's
foot.
98. So you can do it at a different thing. Or you can even, to set that at let's say a 5% parge grade on that,
Yeah.
you could do a 3D, do 2D to 3D by slope from reference. Okay. And that slope from reference, I'm going to make my reference is let's call it a 3D polyline. I think it will read it. So this is the polyline. I want to assign the elevations. And here's my reference polyline. The slope percent, let's say -5%. Done. Okay, so now um, this has an elevation of 1297.65, whereas this is an elevation of 1298. Looking at them together in their 3D,
Yeah, I mean, you want some positive drainage around away from your building.
Yeah, exactly right. That's what we call a parge grade.
Okay.
And then, give
And
me,
then you would start your grading from that contour, right?
yeah, you would start it from this edge here and use that to tie into, uh, whatever.
Existing surface,
Yep. Or whatever.
same way as like we just did.
Exactly right.
Okay.
So you could even, let's take that one, instead of having those corners in it, you could do that same thing, 3D building pad polyline, if I can find it again. Draw building envelope. There we go. 5 foot, take care of building. There it is. Uh, let's see. Like this. All right, so there's that one. And now set the elevations for that. Um, slope from reference. So there's the one to assign. There's my reference. Oh, crap. Try this again. There's the one to assign. There's the reference. And now minus 5%. Done. We look at that in our 3D viewer. And so now we've got this, and you see that 5. Now I've got a vertical
Yeah.
acceleration of, but you can see this, it slopes off to the edges. Now look right in here, because that came up closer. It's still 5% from here, but it's 5% from here. That's why this has this little raised hump. So what I would normally do for that would be what? How would you fix that?
I don't know.
All right. It's just like we did the parking lot up in the upper corners, and we had to adjust those corners. So we're going to adjust these corners. So we're going to go to that tool, 3D data, polyline elevation editor, and we'll select that guy. And it's got all of these as control points. Well, you see, I've got a point here and a point here and a point here. Those are all calculated from those percentages. So I'm going to really hold, this is my 5% here. And I've got a 5%, that's pushed out a different way. So I'm going to hold number 10. So I'm going to say 11, 12, 13, 14. I'm going to let float. So I'll say 11, 12, 13, and 14. And now it's going to come out here to 15. And right there, 16, 17, and 18 were the little hump that goes from 15 up to 16, 17, 18 back down.
Yeah.
You see that right here when you look at, I've got that negative 0.5% right in here. And then I'm going to get to going from there, it goes up and then over, and then down. So if I release the hold on this point, let's say I keep 15, but I release 16, 17, 18, and 19, then that's going to let those float. So if I come down here and release 16, 17, 18, and 19, and I want to set that now, I'm coming into 15 at a negative 0.541. I'm coming into 21 at a negative 1.5. Let's see, maybe 21 is a little low. I'm going to release these two as well. And so I'm coming down to negative 544. I get to 15. Then the next control point is here. And I'm going to make those all basically flat. So I'll make that a 0%. I don't know what's going on with this thing. It's Let's try that again. All right, so now let's come down to point number 10. So we will release 11 through 15 through, so 11, 12, 13, 14 will release. Yeah, see now it's adjusted it. Now we're going to go from 15 down to 20. So we're going to take, we'll hold 15, we'll select 16 through 19, and we will release them. Yeah, there we go. And now maybe even release 20 and 21. Let's release 21. So that's now going to climb back up. So maybe even if I release that one, here's 15, drops a little low there in the front, not by much. And let's maybe even release that one. So it's going to go across there flat. Apply and close. Unknown exception thrown. See, it's time to do a restart. This is why I love Windows and AutoCAD, because it's always giving us problems.
Well, I think it's because maybe you got rid of the corner point as well.
No, that
It
won't.
was trying to like turn a corner, I guess.
Yeah, but that won't cause that. This is a internal programming error. This is an
Oh, okay.
math exception point. So I'm able to locate. Good. So try reprocessing the. I'm able to locate points to add break line. See, it's hung up on something else that was going on in memory. So if you get weird behavior like that, it's best to just restart. But anyway, what you do is those little bump points, as you release the control on them and they float, then they'll interpolate between the endpoints that you hold as control. And so that's why I'm trying to get that to stick now, but this thing is. See, I'm trying to hit cancel. All right. All right, so it did save. Now let's see if I can just exit the damn software and load it back up. Come on. There we go. Let's choose it and see if it kept those changes. If not, now it should have cleared the decks enough to make it work. Let's see if it did. Yeah, there you go. So see, I smoothed out those front bumps.
Yeah.
And you got a couple of them back here. You might want to do the same thing to back in here. And that's because of this offset, because it's computing 5% off of that line, and it comes up here and it's computing 5% off of this line. So that makes that, a different slope out.
There's a chance you could just like draw your own polyline and
Yeah.
ignore those bump outs.
Oh yeah,
And
absolutely.
then that may be a shortcut, I guess, maybe.
Well,
I don't know. I don't know. I'm not that great at the software, but it seems like you could just kind
yeah.
of
So what I would normally do in that
use
particular
the rectangle.
is I would do this. Because I think that's an overhang anyway, right there.
Yeah, it seems like a portrait entry for the building, it looks like to me.
So what I would do I would draw I'm gonna draw a little rectangle and I'm gonna set the corners up here now to match. So now I've got exactly where the building was. I'll just do a standard offset of 5 feet. Get rid of this guy. And you see that was 1298. Let's maybe give that a give it another 3 feet, so make it an 8-foot offset. So maybe I've got something like that. I look at this and I know that's 1298. This is 8 feet away at your -5%. So do the math on that, and that would calculate that to be. Maybe if you don't want to do the math, you could do this, draw a 2D polyline. Let's see. No, let's draw a 3D polyline from this corner here. So that's read that elevation of 1298. See it down there. And I'm going to draw it to be shift perpendicular to that blue line there. So that I just select that. I hover in that grip and look down here, or look in my properties up here. There's the first vertex. There's the second vertex. And so it's 1298. Okay, sorry, I snapped it. So now I need to set that to be 5% down. Okay. Let me even do this a little differently. If I draw a 3D polyline, let's prompt for the elevations this time. I'm not going to put any elevation adder on here. So I'm going to start here. It's going to read, it's going to prompt me for 1298. I'll accept the prompt. Now it wants me to go to another place. And so I'm going to go to shift perpendicular, and I'm going to hit right here, and it reads that elevation, and it wants to, or it's going to keep that same elevation, but I'm going to change it now. So I'm going to use P for percent, and I'm going to say -5%. Okay, so that now applied that to that elevation, and I'm going to hit enter and be done. Now, if I look at this in my properties, there's my 1298. There's my 1297.60.
Drop to 4/10.
So what I would do is this one now is, well, even if that were 0, but to make that one the 1298.60 or 1297.60, I would go to 3D data, change elevations, make it absolute, say okay, and now it says select line work or text of elevation. If I said E to enter, I would have to type in the number. But if I type S to select, it says select line work or text of elevation. So I could even have a piece of text down here and it would read. Or I can go shift right click and choose endpoint right there, that endpoint of that 3D polyline, and be done. Did that? I think I missed something. That's 1298. 1297.60. So that should have set that to 1297.60. Let's do it again. Change elevations, absolute. Say okay. Select line work or text of elevation.
Be your first building pad.
Point right there. Now select, see the end of that. It's snapping to 0 for some reason. Let's see. Now select for
I think it's
elevation.
because your offset's 0.
Are there 2 things here? No, there's just the one.
Hmm.
Well, that's supposed to work. Change elevation, absolute. It now says select line work or text of elevation. So it might be looking for
Can
2D.
you not just click? Can you not just assign an elevation to that outside offset line? Like if you just click on it and then change it in the
Come
properties?
over here and type it if you want. But
Yeah,
you want to snap on it exactly to make it exact. Let's say that was some number with, 8 decimal places.
I got you.
You could do it that way, or you could also do it with this polyline elevation editor again. And we choose this polyline. It's a 2D. So now nothing is set as control. If you set, the first and the end at this, and now say choose the elevation from the screen. So if I choose this elevation from the screen, let me now pick the endpoint of that line. Why does it keep thinking there's two things there? Set the elevation, choose the endpoint of that. Hmm. There's something about me trying to pick. See, I want that to be 1297.6. Now, obviously, I could just type that number in. Um, but you can use a standard CAD edit as well. Let me cancel that. Because if you think about this, where is this line, this outline, where is it in 3D space? It's down at 0 elevation, right?
Mm-hmm.
Let me turn that back to a 2D at 0. All right, so that is and it's a simple polyline at elevation 0. But now, if you think about where that is in 3D space, it's down at 0. This is up here at 1298, drops down to 1297.60. Okay. So what would I do geometrically? I need to move this outline from wherever it is in XY space, but I need to change it. I need to move it up the Z axis till it reaches that elevation. So using just a standard AutoCAD move, I'm going to select it. I'm going to right click and choose move. Now, normally when we think of move, we're going, click and click and we're moving things horizontally. So I'm going to move it I'm going to snap to that corner right there. So I use a reference point to lock me down. I'll click and it's locked. Now specify the second point so if I go to, it wants to know where it's want to go to. Well, I'm going to use what's called a dot filter. So I'm going to say dot XY. So that means read the XY location of, and it says dot XY, select XY of, and I'll select that same point. So it's not going to move it horizontally, and it says still need Z of, see down here on the command line.
Yeah.
So I'll shift right click and choose endpoint, and I'll choose that, boom. And now when I select that, you see it has an elevation here of 1297.60. So those are, you can say dot X, you can say dot XY, you can say dot Y, you can say dot YZ, you can say dot XZ. And anytime you use those, what are called dot filters, you indicate the point and it reads whatever dot you've selected, whether it's dot X, dot Y, dot Z, or dot XY, or dot YZ, or XZ. So it reads that location, then it says, I still need this coordinate value. Okay, so if you want this to be at the same Y coordinate as this one. So you could do the same thing. You could say, let's copy this guy, okay, from here. And I'm going to say, all right, where do I want to put it? Well, if I could just go to another point. So I'm going to say, well, dot Y. So I'm going to say, keep the same Y of, I'll use that same point right there, snap to that endpoint. And now it says still need the XZ of. So if I go over here now and choose this point, it's going to shift. You see where it went to that point in the X, but pushed it up to match the original Y.
Hmm.
And the Z elevation for that now is 1295 because that was the contour I picked, 1295. I must have shifted it a little bit. It should line up across here. But anyway, you get the idea. Those are just standard CAD edits that you, and any way that you choose to do it, you may choose to do it. So now you've got, these two things. You got a building footprint, you got a 5% parts grade down the edges of it, and then use that as your pad, as your building pad template. And then when you build the surfaces, make sure you include the building here, maybe as an exclusion. And so it will triangulate all of this 5% parts grade in here, as you add to that surface. But you're going to use this as the design pad template so that it ties out to the ground from this edge. Right.
Yeah.
That would be right there, design pad template. Let's just call it, we'll keep those same things. So pick a pad polyline, pick the surface, that was our final site, and our slope, let's go to say a 4:1, fill and cut. What did happen there? Surface file, outside ratio. Okay. Pick the pad polyline. There it is. It has elevation. Set my target is my final. Oh, the final site. I didn't.
Yeah, I think you saved your parking lot over your everything.
Yeah, I must have. Sorry. So now so there's my target. Yeah, there you go. So now 4:1, 4:1, and no need to redesign. So that's all in cut because of coming down 5%. So that whole thing would be in cut, and I would look at it, verify it. And that might give me an idea. Well,
You're gonna have to raise your grades.
yeah. So you might want to finish that. Okay.
Yeah.
So those are just, use those tools and that should get you on the way. All right.
All right. I appreciate it.
Well, you are most welcome. I will stop our recording.